Hello and welcome to this course on extracting, transforming, and loading data in Microsoft Power BI. Regular digital activities such as ordering food online, reserving a trip, and using a social media application generate a great deal of data. Now, think about the billions of people who engage in these activities every single day. Then, there are other organizations like universities and banks that perform many other transactions that may need to be stored in different ways. Businesses also need to gather data from different sources, for example, from their customers, from other companies, and from the government. Now, imagine all that data living in different places and being stored in different ways. How can a company make sense of all of this? That's where data analysts come in. One of their jobs is to extract data from different sources, transform it in a way that it can be used, and load it into a tool to help the analysis process, like Power BI. This is what you will learn in this course: how to extract, transform, and load data, a process also known as ETL. Before data can be used to tell a story, it must first be processed so that it is usable as a story. Data analysis is the process of identifying, cleaning, transforming, and modeling data to discover meaningful and useful information. The data is then crafted into a story through reports for analysis to support the critical decision-making process. In this learning path, you will learn about the life and journey of a data analyst and the skills, tasks, and processes they have to master to tell a story with data. You'll discover how getting the data analysis story correct enables businesses to make informed decisions. By now, you should have learned how to harness the power of data in Power BI and how it benefits an organization. In this course, you will get to explore various topics and elements involved in the career of a data analyst, including identifying how to collect data from multiple sources and configuring it in Power BI, preparing and cleaning data for analysis, and inspecting and analyzing ingested data to ensure data integrity. This course will give you a solid foundation in these topics and offer you opportunities to practice extracting, transforming, and loading data into Power BI. Now let's briefly outline the course content so you can have an idea of what's to come in your learning journey as you explore the extract, transform, and load process. First, you will learn about the extract portion of the ETL process. You will focus on data sources and how to extract data and configure storage modes in Power BI. Then, you will move on to the transform portion of the ETL process. You will practice cleaning and transforming data to prepare it for data modeling. You will also learn about data cleaning, using Power Query, and how to use applied steps. Next, you will cover the load portion of ETL and practice using data profiling and advanced queries. You will also learn about referencing queries and data flows and using the advanced editor to modify code. To assist your learning, you will also get to apply your newly gained skills in exercises, quiz questions, and self-reviews. To consolidate your learning and put it into practice, you will complete a practical assignment. In this assignment, you will be provided a business scenario from AdventureWorks, a fictional business, where you need to gather data from multiple data sources to clean and transform. You will have the opportunity to apply the knowledge you gained in this course to join and merge these data sources, identify and remove anomalies using profiling tools. After this practical assignment, you will complete a final graded assessment. Be assured that everything you need to complete the assessment will be covered during your learning, with each lesson made up of video content, readings, and quizzes. In addition, you can share your knowledge and discuss challenges with other learners. These discussions are also a great way to grow your network of contacts in the data analysis world, so be sure to get to know your classmates and stay connected during and after your course. This course is also a great way to prepare for the Microsoft PL300 exam. By passing the PL300 exam, you'll earn the Microsoft Power BI Data Analyst certification. The exam measures your ability to prepare data, model data, visualize and analyze data, and deploy and maintain assets. In this course, you will learn the process of extract, transform, and load. You will identify how to collect data from and configure multiple sources in Power BI and prepare and clean data using Power Query. You'll also have the opportunity to inspect and analyze ingested data to ensure data integrity. Now that you have an overview of what this course is about, it's time to take the next step and prepare for a career as a data analyst using Power BI. These days, businesses generate very large amounts of data through their activities, and the data may come from different sources, for example, from different departments within the company or from clients. The challenge is how to make sense of this data and extract valuable insights that can help improve business performance. That's where Power BI comes in. In this video, you'll explore the basics of data sources produced from business operations and learn how to combine them to gain business insights. To begin, let's first review the data sources that you can connect to in Power BI. Flat files are a common type of data source that can be used for ETL, or extract, load, and transform, in Power BI. Examples of flat files include CSV, TXT, and Microsoft Excel files. Relational data sources, such as SQL Server, MySQL, and Oracle databases, are commonly used by large organizations because they provide a high level of reliability, data integrity, and security. NoSQL databases, such as MongoDB and Cassandra, are becoming increasingly popular for ETL in Power BI. These databases are designed to store and manage large volumes of unstructured or semi-structured data, making them ideal for use in a wide range of applications. Don't worry if you're not familiar with all the terminology, it will be discussed later in this course. So, no matter where your data is stored, Power BI has the flexibility to connect to a wide range of data sources. Next, we will explore how combining data sources in Power BI can optimize supply chain performance. Imagine you are a supply manager responsible for managing the new just-in-time system of your company, ensuring that all parts and materials are sourced and delivered on time while meeting quality standards. You closely collaborate with your team to ensure that the system runs and all suppliers meet their obligations. By combining data from various sources, such as sales figures, inventory, production, and supplier information, your department could gain valuable insights into customer behavior, product performance, and supplier performance. For example, by analyzing sales data alongside supplier data, trends in customer demand can be identified and production and inventory levels adjusted accordingly. On a company level, analyzing supplier performance data helps to identify areas for improvement and work with them to enhance their performance and long-term collaboration. In conclusion, combining data sources can benefit different stakeholders in a business by providing valuable insights into customer behavior, product performance, and supplier performance. This information can be used to make informed decisions, leading to improved supply chain management, reduced costs, increased customer satisfaction, and ultimately drive business success. Data integration can be a daunting task, especially when you are working with multiple data sources that have varying formats, structures, and quality levels. The combination of these sources can often lead to inconsistencies and errors, making it difficult to derive meaningful insights and make informed decisions. But you don't need to worry. Tools like Power BI simplify the process of combining data from different sources, reducing the time and effort required to create a comprehensive view of your data. It is designed to be user-friendly and accessible, even for non-technical users, with an intuitive interface and drag-and-drop functionality that makes it easy to create reports and visualizations. Power BI also allows you to customize your reports and visualizations to suit your company's specific needs. You can choose from a wide range of pre-built templates and visualizations or create your own custom designs. This flexibility makes it easy to create reports that are tailored to the unique needs of your business. It also enables collaboration by allowing you to share your reports and visualizations with colleagues, clients, or stakeholders by sharing reports or embedding them in websites or apps. This collaborative approach can improve communication and ensure that everyone is working with the same data, ultimately driving business success. Combining data sources is a great method of providing valuable information that can lead to improved supply chain management, reduced costs, increased customer satisfaction, and ultimately drive business success. And it should not be a daunting task. In this video, you learned the basics of data sources produced from business operations and how to combine them to gain business insights. Tools like Power BI, with its built-in data connections, can simplify the process of combining data from different sources, reducing the time and effort required to create a comprehensive view of your business. By leveraging the functionalities of Power BI, you, as an aspiring data analyst, along with other stakeholders, can gain a competitive edge and unlock new opportunities for growth and success at AdventureWorks. Every day, businesses generate large amounts of data. But where do they store it all? Many organizations store and export data as files, such as flat files. In this video, you'll learn how to set up and export a flat file data source. Your manager at AdventureWorks, Adio Quinn, asked you to build a Power BI report using a flat file that the Human Resources team has prepared. The file contains some of AdventureWorks' employee data, such as employee names, hire dates, positions, and managers, as well as data located in several other data sources. So, what is a flat file? A flat file is a file type that contains a single data table with a uniform structure for every row of data and does not have hierarchies. Some examples of flat files include comma-separated value, or CSV files, delimited text, or TXT files, and fixed width files. Additionally, output files from various applications, such as Microsoft Excel workbooks, can also be classified as flat files. Now that you know what a flat file is, let me demonstrate how to set up a flat data source. Let's help AdventureWorks' HR department set up a flat data source. The first step is to determine which file location you need to use to export the data. The file location is important because when it is changed, Power BI will not be able to refresh the data. This can cause errors, such as file not found or data source not found. Once you have located your file, you can proceed in Power BI. To display available data sources, in the Home group of the Power BI desktop ribbon, select the Get Data button option or down arrow to open the Common Data Sources list. If the data source you want isn't listed under Common Data Sources, select More to open the Get Data dialog box. In this example, you need an Excel data source, which is first on the list. Next, a connection window displays where you select the Employee Excel workbook that the HR team prepared and select Open. When your HR file is connected to Power BI desktop, the Navigator window opens. This window displays the tables available in your data source, the Excel file in this example. You can select a table to preview its contents and to ensure that the correct data is loaded into the model. After selecting the checkbox of the table that you want to bring into Power BI, it activates the Load button. Now you can select the Load button to import your data into the Power BI dataset. In case you need to change the location of your source file for a data source during development, or if your file storage location changes, you'll need to update your connection strings in Power BI to keep your reports up to date. To do this, in Power BI Desktop, select File in the menu bar, then select Options and Settings from the File menu, and now select Data Source Settings from the Options and Settings menu. You can also change or clear the permissions by selecting Edit or Clear Permissions respectively. Permissions cover the privacy level and credentials used for connecting to a data source. Remember that any structural changes to the file can break the reporting model, so it's important to reconnect to the same file with the same file structure. By following these steps, you'll be able to ensure that your report uses the most accurate and up-to-date information available. You've now helped AdventureWorks' HR department to store their data, and you should now know how to set up and export a flat file data source. Great work! As an aspiring Power BI data analyst, you'll generate large amounts of data. But where can you store this data? Fortunately, Power BI offers several storage options for its users. Over the next few minutes, you'll explore Power BI's storage modes and their impacts on report performance. AdventureWorks need help with creating a report that displays the performance of different product categories over time. This report will be a large sales transaction table with billions of rows. So you need to optimize its performance so that the end users have fast access to the visuals. But before taking on this task, you first need to understand the different storage modes available in Power BI and how they impact report performance. Let's begin with an overview of Power BI's storage modes. Power BI has two primary storage modes, import mode and direct query mode. It also includes a complementary dual mode. Import mode is used to import small data sizes from various sources into Power BI, and it stores it in memory, which enables quick access. For example, in import mode, you can connect to an Excel file containing a data set of available categories. This mode is ideal for the marketing department if they need to filter sales transactions by category in the report view. On the other hand, direct query mode allows you to connect directly to the data source, and the data remains in the source system. Direct query mode is best suited for larger data sets where loading data into memory is not practical. For instance, if you have a card visualization that displays an aggregate summary of category sales from a sales table with this storage mode, Power BI will send a request to the data source and get the result back. By using direct query, the sales department can leverage the power of the external database to handle complex queries and aggregations, while Power BI only brings in the necessary data for visualizations. There are many features in import mode not supported in direct query mode. So it's important to remember that you can't switch from one mode to the other. Now that you're familiar with the two primary storage modes in Power BI, import and direct query, let's explore the complementary dual mode. Dual mode is a distinct mode that combines the benefits of import and direct query modes. When you use dual mode, the Power BI service determines the most efficient mode to use for each query. So, if a table has similar data between import and direct query modes, then using dual mode can be beneficial. With dual mode, you can import the data you need and still use direct query for additional data that is not available in the imported data. Let's explore the advantages and limitations of each of the storage modes in a little more detail, starting with import mode. Import mode is a great option if you need to work with small to medium-sized data sets. Data is loaded into Power BI to form the data model. The data model organizes the data into tables, columns, and relationships, making it more accessible and easier to work with. All calculations are performed within the data model. The data is stored in compressed form, which optimizes memory usage. One downside of import mode is that you must refresh the data manually. This means that any changes you make to the source data will not be reflected in the report until the data is refreshed. The next mode you'll explore is direct query. Direct query mode connects directly to the data source, and queries are sent to the source system in real time. This means that the data is always up to date, and there is no need to refresh the data manually. Direct query mode is best suited for larger data sets, as it does not require loading all the data into memory. If you choose to import the data to a Power BI file stored on your local computer, it will require a significant amount of memory and resource overhead. One downside of using direct query mode is that it can impact performance if the queries are complex or the data source is slow. So you need to consider the benefits and drawbacks of each storage mode and select the one that best suits your needs. The third option you need to be familiar with is dual mode. This is where data is stored in memory, but can also be retrieved from the original data source. This is useful when you are working with dimension tables, which can be queried with fact tables from the same source. For instance, AdventureWorks might have a sales aggregate by customer loyalty table in import mode, which is used to speed up query processing by storing a summarized and categorized version of customer data in memory. Simultaneously, the larger sales transactions table could be set to direct query mode. In this scenario, setting the common dimension table, such as date, to dual mode can enhance the performance of the report. When the dual mode table, date, is combined with an import mode table, sales aggregate by customer loyalty, it behaves like an import table and retrieves data from memory, ensuring faster performance. On the other hand, when the dual mode table dimension date is combined with a direct query mode table, sales, the dual mode table dimension date behaves like a direct query table, querying data directly from the source system. When you use multiple data sources to create a data model, it is called a composite model. Composite models enables you to combine multiple import modes into one unified data model. Using composite models can greatly enhance the functionality and performance of your reports and analytics workflow. When building composite models in Power BI, it's important that you specify the storage mode for each table in your data model. The performance of your composite model depends on how you set it up. For the best performance, try to use import or dual mode tables. They work faster because the data is stored in memory and can be retrieved quickly, giving you faster results. When creating reports, it's essential that you consider the size of your data set and determine if real-time access is a requirement before selecting a storage mode. Power BI offers different storage modes, and in this video, you learned about the two primary storage modes in Power BI, import and direct query, as well as the complementary dual mode. As an aspiring data analyst, it is important that you understand how these different storage modes impact a report's performance. In this video, you explored the advantages and limitations of each of the storage modes. Great work! Data has the potential to help organizations make better business decisions. But businesses generate such large amounts of data they have to sift through that it becomes difficult to see the story it tells. Luckily, Power BI is an excellent tool for visualizing and analyzing data. However, the slow loading time of data can be a significant issue, especially when working with large data sets. In this video, you'll learn how to configure import, direct query, and dual storage modes in Power BI to optimize data retrieval and processing, enhance report speed, and guarantee that your reports always contain the most recent data. Renee Gonzalez, the marketing manager at AdventureWorks, has asked you to create a report that displays sales at the cash registers as customers purchase products. The point-of-sale system scans product barcodes at the cash register, measuring purchase trends. She's concerned with the logistics of ordering, stocking, and selling products while maximizing profit. As this is going to be a large sales transaction table with billions of rows, you need to ensure that the report's performance is optimized so that the end users have fast access to the visuals. To complete this task successfully, you have to select the best storage mode for the data and configure it in Power BI to optimize data retrieval and processing. Let's start by helping AdventureWorks choose a storage mode in Power BI Desktop. To do this, select the Data button on the Home group of the Power BI Desktop ribbon. In the Get Data dialog box, search for the Azure SQL Database Connector. Once you've selected the Azure connector, the Data Connectivity Mode section displays, where you can choose from two options, Import or Direct Query. Import mode stores data directly in Power BI Desktop's memory, while Direct Query retrieves data from your data source in real time. Power BI also provides extra functionality to customize the storage mode for each table in your dataset. To get started, select the Model View icon near the left side of the window to display a view of the existing model. Model View displays all the tables, columns, and relationships in your model. Table card headers are colored to help you quickly identify which tables are from the same kind of source. A table card header with no color indicates that these tables are in import mode. Tables from the same direct query source will display the same color in the table card header, blue in our example. Select the Sales Order Detail DWH table and expand the Properties pane by right-clicking on the table and selecting Properties. The Properties pane displays various options for configuring the table. You'll find a drop-down menu labeled Storage Mode in the Advanced section of the Properties pane. This is where you can set or adjust the table's storage mode. Now, let's set up a dual import mode for your table by configuring the storage mode of the Sales Order Details table. This table is currently set to a direct query mode. In the Advanced section, change the option to Import mode. The following warning message will display. Setting storage mode to import is an irreversible operation. You will not be able to switch it back to direct query. This operation will refresh table set to import, which may take time depending on factors such as data volume. Next, select OK. Congratulations! You now know how to configure storage modes to optimize your reports. Now that the storage modes are configured, Renee and her team should experience a significant improvement in system performance. For example, reports will generate more quickly, they can display real-time data, and business users can access data more efficiently. Well done! At this stage of the course, you should be familiar with how businesses gather and generate large amounts of data in their daily activities. This can include data from human resources, accounting, and sales. You also learned that this data may be structured and stored in different ways. As an aspiring data analyst at AdventureWorks, you will realize that the most important step is to determine how data will be structured and stored. Knowing your data types and the way it is structured gives you the correct data sets to create reports that suit the company's needs, allowing business insights that will help during decision-making. Furthermore, identifying the best storage solution for your data can reduce costs and improve performance, two aspects that any company has as top priorities. By the end of this video, you will be able to identify the difference between structured and unstructured data and what storage solution is ideal for each type. As an aspiring data analyst at AdventureWorks, you've been assigned the task of determining the best storage solution for the online retail website at AdventureWorks. The website was built with 3 data sets used to run the business: product catalog data, image files, and financial business data. Each data set has different requirements. The key factors to consider in your task are data classification, how your data will be used, and how you can get the best application performance. Now, let's focus on data types. There are 3 types of data: structured, unstructured, and semi-structured, all of which are suitable for analysis but differ in the tools used for ingestion, transformation, and storage. Let's start with structured data. Structured data is the most common type of data that we use. It is also known as relational data. In a financial report, for example, numbers and names are arranged into columns and rows, making it easier for analysis and processing. By nature, structured data is quantitative, easily searchable, sortable, and analyzed using tools like Microsoft Excel spreadsheets or relational databases, which can store large amounts of structured data. SQL, or Structured Query Language, is a programming language used to manage relational databases. It allows users to manipulate and query data stored in a database, making it a valuable tool that's used by data analysts and business users. However, the structure makes any addition or removal of data fields difficult, since you must update each record to adjust to the new structure. Some applications where relational data is used are customer relationship management, reservations, and inventory management systems. Now, let's cover unstructured data. Unstructured data does not have a predefined structure or format. It is best used for qualitative analysis and usually resides in non-relational databases or unprocessed file formats. Some examples of this type of data are text documents, audio and video files, social media posts, and images. These types of files can be stored in a centralized repository that ingests and stores large volumes of data in its original form. Then there is a third type of data. It is called semi-structured data because it is not as organized as structured data and it is not stored in relational databases. This type of data uses tags for organization and hierarchy. Video files may have an overall structured and contain semi-structured metadata, but they are considered unstructured data since the data that forms the video itself is unstructured. There is a process for converting semi-structured data into a specific format that can be easily transmitted, stored, or processed. It is called data serialization. It uses a method of formatting that will allow the data to be transmitted or stored in a way that is easily understood by both the sender and the receiver, without the need to know all the specific details of the data. This is useful when dealing with semi-structured data that doesn't fit neatly into traditional databases or data structures. If you want to learn more about serialization, please visit the additional resources at the end of this lesson. Now, you'll learn how to classify your data in order to choose a suitable storage solution for structured or unstructured data. The correct storage solution can deliver better performance, improve manageability, and save on database costs. When selecting a storage solution, it's important to consider the type of data you're working with, what operations are needed to transform the data, and what level of management and maintenance is required. The business data used at AdventureWorks for analysis on a year-to-year comparison is not updated frequently. It is stored in multiple data sets, and some latency can be accepted. Since it is mainly read-only, not all data analysts need write access, but they can all read from all data sets. This is a type of structured data that will most likely be queried by data analysts who use SQL more than any other query language. Therefore, a suitable storage solution for this example is a SQL database or a cloud-based solution like Azure SQL Database, but it can also be bundled with another cloud-based solution, Azure Analysis Services, to model the data in Azure SQL Database. This model can be shared with business users who can connect to it through Power BI for analysis and gain business insights. In summary, selecting the appropriate storage solution is vital for addressing the specific requirements of your data. Remember when we spoke about serialization and the formatting to allow the storage of unstructured or semi-structured data? One of those formats is a blob. This is a binary large object where the data is stored in a binary ones and zeros format. For AdventureWorks' online retail website, Azure Blob Storage is an ideal option for storing unstructured data such as photos and videos. It's a scalable and cost-effective cloud storage service which is designed to store large amounts of unstructured data, such as images, videos, or documents. The website has a product page where a bicycle photo needs to be displayed at the same time as the specific bicycle model. The photos will not be queried independently. By including the photo ID or URL as a product property, the photo can be retrieved by its ID without any time lag. This demonstrates how unstructured data can be stored. The right storage solution allows AdventureWorks to achieve optimal performance and efficient data management. In this video, you learned that while structured data is easier to work with and analyze, unstructured data is often more abundant and valuable. Businesses and organizations are increasingly focusing on harnessing unstructured data to gain insights into customer behavior, emotions, and other aspects that can shape their strategies. Choosing and implementing the correct storage solution can benefit companies and organizations by improving performance, reducing costs, and increasing efficiency. AdventureWorks generates data from many different departments and stores this data in many different sources. Wouldn't it be great if they could combine data from these different sources? With Power BI, they can combine data sources using connectors. In this video, you'll learn about the different kinds of connectors available in Power BI, their purpose, how to choose a connector, and securely connect to the cloud data source. AdventureWorks needs to generate a report that compares the sale of bicycle models across the company's different outlets, web, retail, and individual sellers. However, the sales data is stored in different sources. The company needs you to generate an integrated report that combines these different data sources. You can combine these data sources using connectors in Power BI. You can use Power BI as a single business intelligence solution to generate an integrated report by combining the company's data sources through the use of connectors. But before you begin, let's find out more about connectors. Connectors are links that transport data between a data source and an application. They're basically the bridges that connect Power BI to different sources of data. With connectors, you can create a link or bridge between Power BI and different data sources like databases, files, services, SharePoint, and more. Connectors make it easy to connect between data sources. You can then transform, clean, and visualize the data into Power BI for report and analysis to generate insights. But before you start importing your data, it's important to understand what your business requirements are for the data source. This includes things like whether the data is stored on your own computer and gets updated every so often, or if the data is coming from an external source and needs to be updated in real time. You also need to know who will be using the data and how it will be used. These requirements are essential because they can affect the way you load the data into Power BI. So it's important that you get them right. Microsoft frequently adds new data connectors to its desktop and services platforms. It typically releases at least 1 or 2 new connectors every month as part of the regular Power BI update. This has resulted in Power BI having a vast collection of over 100 data connectors available. Files, databases, and web services are the most used sources. All Power BI connectors are free to use, but they might be marked as beta or preview depending on their development stage. Any data source marked as beta or preview has limited support and functionality, so don't make use of it in production environments. Now that you're familiar with the data connectors available in Power BI, it's time to help AdventureWorks generate their report. Let's examine the steps involved in setting up a connector to a SQL database. First, navigate to the Home tab and locate the Get Data button. You have 2 options to choose from here. You can either select the Get Data button and then choose All, or you can select the expand arrow next to the Get Data button and select More. This lets you access a wide range of data connectors available in Power BI. To make sure your data is mapped correctly in Power BI, it's crucial to identify the specific nature of the data. For instance, if you're working with a document meant for an Azure SQL database, using the Excel connector wouldn't give you the desired outcome as a Power BI user. In the Get Data window, navigate to the Azure SQL option and select it. Then select the Connect button. You can also use the search bar to filter the available connectors and quickly find what you're looking for. After selecting the data source, you'll be prompted to set up the connection. Depending on the type of data source you've chosen, the specific details you need to provide will differ. For example, if you're working with an Excel file, you'll need to specify the location of the file. On the other hand, if you're dealing with a SQL Server database, you'll need to enter the server name and the database connection details. There are a few additional options you may want to consider. In addition to specifying the server address and database name, you can also choose between different connection modes, such as import or direct query. Most of the time, you'll select import. Other advanced options are also available in the SQL Server database window, but you can ignore them for now. You'll cover them at a later stage in the course. After you've specified the server and database names, you'll be prompted to sign in with a username and password. You'll have 3 different sign-in options to choose from, depending on your credentials. The first option is to use your Windows account. This is often the easiest option for users who are already logged into their computer. The second option is to use your database credentials. For instance, SQL Server has its own sign-in and authentication credentials that are managed by the database administrator. The third option is to use your Microsoft account credentials, which require your Azure Active Directory credentials. Once you've selected the sign-in option that's appropriate for your situation, enter your username and password, and then select Connect. This will allow you to securely connect to your data source. Once you've successfully connected your database to Power BI Desktop, the available data in the Navigator window appears. This window displays all the tables or entities that are available in your data source, such as the SQL database in this example. To preview the contents of a table or entity, simply select the checkbox next to the table. To import data into your Power BI model, select all tables that you want to bring in. Finally, once you've selected the tables, you can choose to either load the data into your model in its current state or transform it before loading. For now, the focus is on the data loading process. Data transformation will be covered in more detail at a later stage. By selecting the appropriate data and choosing the load option, you can easily bring in the data you need to start building visualization and analyzing your data in Power BI. Connectors are an essential component of Power BI. The wide range of available connectors lets you connect to lots of different data sources to bring them all together into one place. You can then import or extract the data from these sources into reports and dashboards for analysis and visualization. By leveraging the full range of connectors, you can access valuable insights to make data-driven decisions for your business. You should now understand that connectors are a powerful asset that can help you get the most out of your data analysis. What if you could reorder products you buy frequently with a click of a button? That would be really convenient, right? And what if other types of tasks could be automated by businesses? Well, in today's data-driven world, organizations are constantly searching for ways to automate tasks to optimize productivity. Microsoft Power BI is an integrated suite of software tools, applications, and connectors that can help you transform your data sources into clear and compelling visualizations. Connectors play an important role in connecting to various data sources and executing actions or triggering workflows based on specific events. There are two types of operations available to create automated workflows: triggers and actions. In this video, you will explore how actions are triggered to create efficient and effective scheduled actions. So, let's get started with triggers and actions in Power BI. Adio Quinn, a data analyst at AdventureWorks, a bicycle manufacturer, is responsible for analyzing daily sales reports and providing insights to the management team. However, the manual process of importing data from multiple sources and analyzing it can be laborious and time-consuming. To streamline this process, Adio asks your help to leverage Power BI's triggers and actions to automate the workflow. With Power BI, you can schedule an action to refresh the data and email the latest sales report to the management team. With this automated workflow in place, you can now focus on analyzing the data and providing valuable insights to the management team without worrying about the manual process of importing and analyzing the data. In Power BI, triggers and actions work together in configuring a workflow, either based on time or specific actions. A trigger is always required to initiate a workflow and prompt it to run. Additionally, actions in Power BI enable interaction with the data source through various functions. Automating tasks and processes with actions in your workflow can save time, reduce manual effort, and make your workflow more efficient. Moreover, scheduled actions in Power BI can automate tasks and actions based on specific time intervals. By setting up a schedule, reports and dashboards can be updated with the latest data regularly without manual intervention, thereby improving data accuracy and streamlining workflows. Now, we are going to explore how to set up a scheduled data refresh. When it comes to working with data in an organization, having access to the latest and most relevant information is essential. Outdated data won't be useful to the organization as it doesn't reflect the current situation. Relying on old data can even hinder the organization's growth, since there could be more recent and applicable data readily available. In this video, we'll explore the topic of automating tasks in Power BI. In Power BI, users have the option to create scheduled actions, which enable them to automate tasks and actions at specified time intervals. Today, you are going to help Adio, a data analyst at AdventureWorks, and his job involves regularly updating sales report datasets according to a predetermined schedule. By setting up a scheduled data refresh, Adio can now automate the process, saving him valuable time and effort. Let's begin by opening your browser and heading to https://app.powerbi.com/home to get to the scheduled refresh screen. In the navigation pane on the left-hand side of the screen, select Data Hub. Next, locate the dataset you wish to work with. In our case, the sales report dataset. Next, select the ellipses and then select Settings to expand the dataset settings. This will take you to a new screen where you can configure the trigger. Scheduled Refresh section is where you define the frequency and time slots to refresh the dataset. Let's walk you through the steps to set up an online refresh schedule in Power BI services. Here's what you need to do. Step 1. Turn the switch to On. Step 2. You can modify the schedule to fit your needs. Choose the frequency you want the dataset to refresh, such as daily. Select the time zone you want to use, for example, UTC London. Under Time, select Add Another Time and enter a time for the refresh to occur. Repeat this step for additional refresh times as needed. Step 3. Once you're done, simply select Apply and you're all set. Did you know that you can easily adjust the frequency, time zone, and time of your scheduled refreshes in Power BI? This allows you to ensure that your data is always up to date and accurate. Plus, you can even set up scheduled notifications to be sent to a specific email address. How convenient is that? Beware, if your data set hasn't been active for 2 months, the scheduled refresh will be automatically paused. Are you ready for a quick rundown on data refreshing in Power BI? Great! As a Power BI user, refreshing data typically means importing data from the original data sources into a data set. You can choose to refresh data based on a predetermined schedule or on demand, depending on your needs. If your underlying source data changes frequently, it may be necessary to perform multiple dataset refreshes daily. However, it's important to note that Power BI limits datasets on shared capacity to a maximum of 8 scheduled daily dataset refreshes. With these easy steps, you can now create a refresh schedule that works perfectly for you. In this video, you explored the topic of automating tasks within Power BI, specifically using scheduled actions to automate tasks and actions at specified time intervals. By automating processes such as data refreshing, users can save valuable time and effort. We walked through the steps to set up an online refresh schedule in Power BI services and highlighted the importance of periodically checking the refresh status and history to ensure data sets are error-free. Good job! Congratulations on reaching the end of the first week in this course on how to extract, transform, and load data in Power BI. This week, you explored how to work with basic and advanced data sources in Power BI. Let's now take a few minutes to recap what you learned this week. This summary will help you review the concepts presented previously and clear up questions you might have. You began the course by covering basic data sources. You learned that, for example, by analyzing sales data alongside supplier data, you can identify trends in customer demand. You also learned that data from different parts of an organization may come from different sources and may be stored in different ways. That's when you identified the many different data sources supported by Power BI, like flat files, relational data sources, and NoSQL databases. You also learned how to set up a flat data source. After that, you learned that local datasets provide data that is only available to a specific individual or organization and are typically stored locally. Local datasets are a good option for organizations or projects with few users that demand high security and need speed over quantity. On the other hand, shared datasets allow multiple individuals or organizations access to data and are usually stored on multiple locations or cloud-based platforms. They are suitable for large enterprises or projects that require multiple users working at the same time. Then, you had the opportunity to complete a practical exercise on how to set up an Excel data source in Power BI. After that, you covered different storage modes in Power BI. You learned that you must think carefully about the benefits and limitations of each storage mode and select the one that best suits your needs. Import mode is a great option if you are working with small to medium-sized data sets and if the data is loaded into Power BI data model. In this model, data must be refreshed manually. On the other hand, direct query mode connects directly to the data source, and queries are sent to the source in real time, so there's no need to refresh the data manually. However, this mode might impact performance. You also covered dual and hybrid modes as alternative storage modes. After you explored these different storage modes, you then learned how to configure them in Power BI. Next, you had the opportunity to apply your skills and configure storage modes in Power BI. You discovered that structured data, also known as relational data, is arranged into columns and rows. By nature, structured data is quantitative, easily searchable, sortable, and analyzed using tools like Microsoft Excel spreadsheets or relational databases, which can store large amounts of structured data. On the other hand, unstructured data does not have a predefined structure or format. Unstructured data is best used for qualitative analysis and usually resides in non-relational databases or unprocessed file formats. Some examples of this type of data are text documents, audio and video files, social media posts, and images. Semi-structured data is not as organized as structured data, and it is not stored in relational databases. This type of data uses tags for organization and hierarchy. An example of semi-structured data is video files. You then learned about connectors. Connectors are the bridges that connect Power BI to different sources. With connectors, you can import data from databases, files, Outlook, servers, SharePoint, and many other sources. You also learned that before you start importing your data, it's important to understand what your business requirements are for the data source. You then explored the two types of operations used for creating automatic workflows, triggers and actions. Triggers are used to create efficient and effective scheduled actions. For example, AdventureWorks can use triggers to automate parts of their Power BI workflow, like refreshing data and emailing reports. Next, you undertook another practical exercise. In this exercise, you implemented triggers to automate your workflow in Power BI. You then tested your understanding of the concepts that you encountered in this lesson in the knowledge check. Finally, you undertook a module quiz. This quiz tested your understanding of all concepts that you explored in this module. You should now be familiar with the fundamentals of data sources. You should be capable of extracting data from basic and advanced data sources to work with in Power BI. Great work! I look forward to guiding you through the next week's lessons, in which you'll learn about transforming data in Power BI. You're making progress in your journey to become a data analyst. You've learned how to extract data, and now it's time to learn how to transform it so you can make better use of it. Depending on your data sources, data transformation can involve different activities, such as cleaning, merging, and profiling. In this video, you'll learn how to identify components of data transformation and understand why data transformation is required. AdventureWorks CEO Jamie Lee has set a new goal for the company to increase sales. She's relying on company data to uncover trends and insights and make that goal achievable. Your manager, Adio Quinn, has asked you to create a Power BI report that visualizes the data in a meaningful way. But before you can start working with that data, you need to clean and transform the raw data to ensure its accuracy and consistency. In the first part of this course, when you explored the extract stage of the extract, transform, load process, you learned that data may come from different sources. However, the data from these sources may contain inconsistencies that make accurate analysis difficult. Data from different sources can be untidy, incomplete, and inconsistent, making it difficult to draw meaningful insights. That's why data transformation is a crucial step. It helps you prepare data for analysis. Now, let's examine some of the inconsistencies you may find in data. By this point in the course, you should know that data is classified into three main groups called structured, semi-structured, and unstructured data. Each data group is suitable for analysis but may require different tools to ingest, transform, and store. You can say that data coming from sources that you define as structured data is more ideal to work with and compliant with the rules, since these sources are systems that have strict rules and prioritize data integrity. Data coming from conventional databases generally have a low probability of inconsistent or erroneous data. However, in semi-structured data, unstructured data, and even in some types of structured data, it is likely that there is data that needs to be transformed before starting the report design. For example, let's say you are working on an analysis related to products in an e-commerce database. For this task, you need some relevant fields for your report. However, the table has hundreds of fields, so you need to decide how to identify the relevant data to create your report. An example of useful data transformation in this scenario is including certain columns from the data and excluding others before loading the data for analysis and reporting. Another transform example would be selecting fields and transforming by merging them, such as in a customer table with fields for the first and last name, but you want to display them as a single full name field by merging fields with a space between. Now, let's explore what data cleaning is. Data that is not structured is more flexible in terms of rules and therefore more likely to be disorganized and require cleaning. You may not encounter as clean data as you would expect in Excel data or in data organized using delimiter symbols such as angle brackets or commas. In such cases, the data should have a preliminary examination to identify incorrect data or separate rows where content refers to the same values, like where, house, written as 2 words, and warehouse as in 1 word. You can resolve these inconsistencies by passing them through filters with specific rules. This examination is referred to as data cleaning. Another data issue you may encounter is the need to merge or append multiple data sources. For example, if AdventureWorks has 2 data sources for sales, one for online sales and another for in-person sales, you'll need the data from both to create a monthly sales report. Depending on the data formats, you can use commands such as append or merge data transformations to combine the data for analysis. In this video, you learned that data transformation can help improve data quality by removing errors, inconsistencies, and inaccuracies. This results in cleaner, more reliable data for analysis. It also allows you to standardize data when working with multiple sources. With data transformation, you can help organizations like AdventureWorks use data that is more understandable, organized, and consistent to achieve goals like increased sales. In this video, you will explore some features of Power Query and learn to navigate the Power Query editor interface. Adio Quinn, the data analyst at AdventureWorks, asks you to clean and transform the company's sales data, which is scattered across multiple sources in preparation for data analysis. Power Query can help you with this. Power Query is part of Power BI Desktop, allowing for seamless data preparation within the Power BI environment. Power Query is a data transformation and data preparation tool, allowing you to connect, clean, and transform data from a wide range of sources. It ensures that your data is ready for analysis, enabling you to create insightful visualizations and reports. Let's explore how Power Query helps you clean, shape, and organize data from various sources. The first feature is data connectivity. Power Query connects to various data sources, both on-premises and the cloud, directly within Power BI Desktop. You can access data from traditional databases as well as file-based sources. Next, there's data extraction and transformation. Power Query's interface allows you to extract and transform data with ease. During the extraction process, you can filter, sort, and apply custom transformations, ensuring that you import only the required data. Then, there's the Power Query editor in Power BI within Power BI Desktop, which provides a graphical user interface, or GUI, for designing and managing queries. Tabs such as Home, Transform, Add Column, and View have data manipulation tools. There's also query reusability and applied steps. Power Query records each transformation as an applied step, allowing you to review, modify, or delete any step. This ensures that your data transformations are transparent and easily modifiable. Finally, there's performance and scalability. Power Query handles large data sets efficiently, using various techniques that optimize performance and reduce memory usage. Let's demonstrate these features in Power Query. To achieve Jamie's goal of increasing sales, you must work with sales data from different regional teams stored in different file formats like Excel, CSV, and even a SQL database. To get started, you'll need to import this data into Power BI using Power Query. To begin the import, you must add a data source. In the Power BI Desktop, in the Home tab, select Get Data to choose a data source. The Power Query editor opens in a separate Power BI window where you can apply various data transformations, such as removing columns, changing data types, and filtering data. Next, you need to load the data, select your data source, and configure the connection settings if necessary. Select Transform Data to open the Power Query editor. Now, let's discover how to navigate in Power Query. The Power Query editor has several key areas. Let's start with the ribbon. The ribbon is the set of toolbars at the top of the window. It helps you quickly find the commands that you need to complete your tasks. The ribbon tabs, such as Home, Transform, Add Column, and View, contain commands and tools for data transformation and manipulation. The Queries pane is located on the left side of the editor. The Queries pane displays a list of all the queries in your project. Select a query to view or edit its applied steps and data preview. This pane is where you can manage and navigate between different queries in your project. By selecting a query, you can view the data and the applied steps associated with it, helping you keep track of your work and maintain organization in your project. Then, on the right pane, below the ribbon, there's the Applied Steps section. It displays the sequence of transformations applied to the selected query. Select a step to view the data state at that point, or delete, reorder, or modify steps as needed. The Applied Steps section provides a visual representation of the transformations applied to your data, making it easier to understand the changes made. By reviewing the applied steps, you can identify errors, redundancies, or inefficiencies in your data transformations. Finally, in the center of the Power Query window, let's explore Data Preview. The Data Preview pane displays a preview of your data as it appears after the applied transformations. You can interact with the data by sorting, filtering, or changing the data type of columns. This pane enables you to review your data at different stages of the transformation process, helping you to get your transformations accurate and effective before loading the data into the data model. In this video, you learned that Power Query is a versatile tool in Power BI that streamlines data import, cleaning, and transformation from multiple sources. Its features, such as data connectivity, data extraction, and transformation, make it an integral part of Power BI Desktop. It helps you prepare and transform data from different sources within AdventureWorks to simplify analysis and create insightful visualizations and reports. The Power Query Editor interface offers a user-friendly experience, allowing you to perform various data transformations with ease. Thanks to the Applied Steps list in Power Query, you can easily undo and reorder steps without losing progress. In this video, you'll learn how to use the Applied Steps list to undo, modify, and reorder steps. First, let's open the Power Query Editor in Power BI. To do this, from the Home tab, select Transform Data. After selecting your data source, the Power Query Editor opens in a separate window. Next, let's locate the Applied Steps list. In the Power Query Editor, you'll find the Applied Steps list on the right pane below the ribbon. It has all the steps you've performed on your data, presented in the order of application. The Applied Steps list is a visual representation of the transformations applied to your data. By reviewing the applied steps, you can identify errors, redundancies, or inefficiencies in your data transformations. To view the data state at a specific point in the process, select the corresponding step in the Applied Steps list. The Applied Steps list makes it easy to correct a mistake, or change your mind, or undo a transformation. To undo a step, simply select the X icon next to the step to remove. Power Query will automatically revert the data to the state it was in before that step was applied. Please note that removing a step will also remove all subsequent steps in the list, as they are dependent on the previous transformations. What if you need to reorder the sequence of steps? To reorder steps, select and drag the step you'd like to move to a new position in the list. Power Query will update the data accordingly, applying the transformations in the new sequence. You should note that reordering steps might affect the results of subsequent transformations. Review your data and the Applied Steps list to check everything. Suppose you need to modify a step. Just select the gear icon next to the step. This opens a settings window to edit the transformation parameters. When changed, select OK to apply the update. As with reordering steps, modifying a step might affect subsequent transformations. Always review your data and the Applied Steps list to ensure everything is as expected. To add a new step, use the Power Query Editor ribbon to choose a transformation, such as filtering or sorting. When you perform a new data transformation, it's added to the Applied Steps list. With the Power Query Editor, you can also add filters. Filtering is the process of narrowing down your dataset by displaying only the rows that meet specific criteria. It helps focus on a particular subset of data, remove unwanted data that may affect your analysis, or simplify your dataset for better readability. Let's check how to add a filter. In the Power Query Editor, select the column header for the column you want to filter. This highlights the entire column. With the column selected, select the small down arrow next to the column header. This opens a drop-down menu with filtering options such as text filters, number filters, or date filters, depending on the data type in the column. Choose the type of filter and select OK. Notice the new filtering step has been added to the Applied Steps list. You can also sort your data set. Sorting is the process of arranging your data in a specific order, either ascending or descending. Sorting organizes data based on specific attributes, such as alphabetical order, numerical values, or chronological order, helping to identify the highest or lowest values in a dataset. Select the column header for the column you want to sort. In the Home tab of the ribbon, find the Sort group. Choose Sort Ascending, A to Z, or Sort Descending, Z to A, to sort the selected column in ascending or descending order. The data is sorted based on your chosen sorting order. Check the Applied Steps list to ensure the new sorting step is added. Finally, for better organization and readability, you can rename any step in the Applied Steps list. Just right-click the step you'd like to rename and select Rename. Enter a new descriptive name for the step and press Enter. Renaming steps helps keep track of transformations, making it easier to navigate and understand the data transformation process. In this video, you learned how to use the Applied Steps list in Power Query to undo, modify, and reorder steps. It has a visual representation of the data transformation process, making it easier to understand complex queries and track the impact of each action on the dataset. The Applied Steps list provides easy undo and redo functionality, flexibility and reordering steps, and efficient troubleshooting capabilities, saving time and effort. How do you efficiently remove and rename columns to focus on the data that matters? You can do it with Microsoft Power Query and Microsoft Power BI. In this video, you'll learn how to remove and rename columns and promote header roles in Power Query in Power BI. As you continue to work on AdventureWorks' goal to increase sales, your manager, Adio Quinn, asks you to prepare a report on sales and customer demographics. You have a data set with numerous columns, but you only need a few of those columns for your analysis. You must get the data organized and streamlined, but you're not sure where to start. That's where Power Query comes in. Power Query is a powerful data transformation tool within Power BI that allows you to connect to different data sources, clean data, and transform data with ease. A common data manipulation you'll encounter is working with columns. Working with columns in Power Query and Power BI is an essential skill for data analysts and professionals who regularly deal with data. One of the main benefits of learning to work with columns is efficient data preparation. Eliminating unimportant or repetitive columns allows you to concentrate on the most crucial data for your analysis, minimizing the dataset size and streamlining the data structure for easier manipulation and quicker processing. Another benefit of working with columns is improved data readability and interpretation. Removing unnecessary columns helps declutter your dataset, making it easier to read and understand. Renaming columns with more descriptive names helps you quickly identify the purpose and content of each column. One other benefit of working with columns is that it allows for enhanced data analysis and reporting. By focusing on the most relevant columns, you can produce more accurate and meaningful analyses. This allows you to deliver actionable insights to your team and organization, leading to better decision-making. Finally, working with columns means time and resource savings. Efficiently removing and renaming columns in Power Query can save you a significant amount of time during the data preparation stage. This means you can devote more time to analyzing the data and generating insights. By streamlining your data preparation process, you'll also reduce the computational resources required to process your data. This can lead to faster analysis and, in some cases, cost savings, particularly when working with cloud-based services that charge based on resource usage. Now, let's explore a step-by-step guide on how to remove and rename columns and promote header rows in Power Query. Let's start by demonstrating how to remove columns. The first step is to load your data into Power Query Editor. Open Power BI. On the ribbon, select Home. Select Get Data and choose your data source, for example, Excel or CSV. Once connected to your data, the Power Query Editor opens, displaying your data. The next step in the Power Query Editor is to locate the columns you want to remove. To select a single column, select its header. If you need to select multiple columns, hold down the keyboard Control key or the Command key if you're using a Mac, and select multiple column headers to remove. With the columns you want selected, you're ready to proceed. Right-click on any of the selected column headers. In the context menu that appears, select Remove Columns. The selected columns are removed from your dataset. You will notice a new step, Removed Columns, appears in the Applied Steps list on the right pane, reflecting the updated data state. Now, let's cover how to rename columns. First, you select the column you want to rename. In the Power Query Editor, select the header of the column to rename. Right-click the header of the selected column. In the context menu, select Rename. A text box appears. Type in a new column name. Press Enter to save the change. Again, you'll notice the new step in the Applied Steps list. Let's check how to promote header rows. The first thing is to identify which row in your dataset contains the headers. In most cases, this is the first row. If your dataset has additional information or metadata above the headers, you may need to scroll down to find the appropriate row. Now you can promote the header row. Once you've identified the header row on the ribbon, use the Home tab to locate the Transform group. Select Use First Row as Headers. This promotes the first row to be used as column headers, replacing the existing headers. Note, if the header row isn't the first row, you'll need to remove any rows above the header row before promoting it. To do this, select the rows you want to remove by selecting the row numbers on the left side of the editor. Then, on the ribbon in the Home tab, select Remove Rows. You will notice a new step, Removed Rows, in the Applied Steps list on the right pane, reflecting the updated data state. In this video, you learned how to remove and rename columns in Power Query. You also learned how to promote header rows. These are important skills for you to master as an aspiring data analyst. They empower you to transform raw data into valuable insights that drive smarter decision-making and lead to a greater impact within your organization. Furthermore, efficient data preparation saves time and computational resources. When analyzing your data, you need to ensure accuracy and reliability. But datasets often contain errors that lead to inaccurate results. Using Power Query, you can fix many common dataset errors. In this video, you'll learn how to identify common types of errors and discover how best to fix them using Power Query in Power BI. AdventureWorks is preparing to analyze its latest sales data worksheet. However, there are several errors in this dataset, like null values, duplicate rows, and inconsistent data types. These errors must be resolved before analysis. Let's take a few moments to help AdventureWorks fix these errors using Power Query. First, you must import the dataset to transform. In this case, it's the AdventureWorks sales dataset. On the Home tab, select Get Data and choose Text CSV for the file type. Browse to the location of your dataset and select Open to import. Then select Load to load the data. Next, select Transform Data in Power BI Desktop. The Transform Data button is in the Home tab in the Queries group of functions. The button is positioned to the right of the Recent Sources button. The sales data is loaded into Power Query. It shows a list of bicycle products and key information about each product, like name, price, weight, category, and description. However, several of these rows contain null or missing values. These errors need to be resolved before the data can be analyzed. To systematically identify missing or null values, select the drop-down arrow in the column header for the variable you're examining. This opens a filter menu used to filter the data in the column based on specific criteria. The filter menu contains options like empty or null. Available options depend on the data type of the column. Empty refers to blank cells in text columns. Null refers to missing values in numeric or date columns. Select the appropriate option to filter and display rows that contain missing or null values in the selected column. Inspect the data table in the editor and identify any rows with missing or null values. In this data set, 2 rows contain missing values. Row 16 and row 17 have a missing value in the product subcategory column. Now that you've identified the values, you can resolve them. There are 3 ways to resolve missing values. You can replace them with default values, replace them with values from another column, or remove the rows containing missing values. For AdventureWorks, the best approach is to replace its missing values with default values. Logical default values can represent the missing data without distorting the analysis or visualizations. First, in the ribbon at the top of the editor, select the Transform tab. You use this tab to access the tools and functions for modifying and transforming the data. Next, select the Replace Values button. Then select Replace Values from the drop-down menu. You use this option to replace specific values in a column with a new value. In this case, you can replace all null or missing values. A Replace Values dialog box appears on screen. It has a text box labeled Value to Find, where you specify the value you want Power Query to identify and replace. The aim is to find missing or null values in the product subcategory column. So in the Value to Find box, you can write null. Below the Value to Find box, there's another text box labeled Replace With. This is where you type the new value you want to replace the missing or null values with. The new value should be consistent with the column's data type, which is text. So let's replace the missing values in the product subcategory with the text value trail, which represents the default category for trail bikes. Finally, select OK to confirm and make the change. When you select the OK button in the Replace Values dialog box, Power Query scans the sheet for the values you instructed it to identify. It then replaces each instance of these values based on the criteria you specified in the Replace With box. You can review a history of all data transformation operations you've applied to the dataset by selecting the pane called Applied Steps on the right-hand side of the Power Query Editor window. AdventureWorks has fixed the null values in its dataset, but there are still duplicate rows errors present. The entries in rows 22 to 24 are duplicates of other records in the sheet, and identical records also exist in rows 25 to 27. Let's help AdventureWorks resolve these errors. On the Home tab, access the Data Manipulation functions. From these functions, select the Remove Rows option, and a drop-down menu appears. Select Remove Duplicates from the options. Power Query analyzes the dataset and finds rows that have identical values in the selected columns. It then removes all but one instance of each group of duplicates. That's good progress. Just one final error left in the dataset: inconsistent data types in the form of order dates. Let's fix this final error. The inconsistent data is in the column Order Date. Select the column header to select and apply changes to the entire column. Next, select the Transform tab to access the data modification options. Select the Data Type button. Then select the Date data type from the drop-down menu. This converts all values in the column to the selected data type, meaning all data types in the column are now consistent. Thanks to your help, AdventureWorks has removed all errors from its dataset. It can now perform data analysis without the risk of producing inaccurate results. You should now understand how to identify common errors in datasets, like missing or null values, duplicate rows, and inconsistent data types. You should also be able to resolve these issues using the tools available in Power Query. Identifying and resolving these errors is essential for making sure your analysis runs on accurate, reliable, and high-quality data. You are a data analyst at AdventureWorks, tasked with analyzing sales data across different product categories and regions using Power BI. Understanding the importance of reshaping the data to uncover valuable insights, you know you'll need to transform the data. So far in your introduction to transforming data in Power BI in this course, you've learned about Power Query, data types, columns, and preparing a data set. In this video, you'll gain further insight into Power BI's powerful data transformation capabilities by discovering unpivoting and pivoting in Microsoft Power Query. Unpivot and pivot operations are data transformation techniques that you can use to reshape and restructure data in Power BI. Let's explore each operation in turn. The unpivot operation refers to the transformation of data from a wide format with multiple columns to a narrow format with fewer columns by reshaping the data structure. It involves converting column headers into row values, resulting in a more structured and standardized representation of the data. The unpivot operation is useful in data analysis, supporting data normalization by organizing data in a tabular format. This facilitates analysis, variable comparison, and data aggregation and summary, as related information is consolidated into a single column. Transforming data from a wide to a narrow structure can also enable data compatibility and integration with other systems or tools that require a narrow format. For example, in the case of the AdventureWorks sales analysis, you can perform the unpivot operation to convert the sales data, which is organized in a wide format with separate columns for each region, into a long format where the region-specific data is stacked vertically in a single column. This makes it easier to compare sales across different regions and gain a holistic view of the overall performance. On the other hand, the pivot operation refers to the transformation of data from a narrow format with fewer columns to a wide format with multiple columns by reorganizing the data structure. It enables data analysts to convert rows into columns based on specific criteria or values. This operation is often used to summarize and aggregate data, create cross-tabulations, and represent data in a more structured, easy-to-understand way for analysis and reporting. To illustrate, say you want to analyze the sales data based on different product categories as part of the AdventureWorks sales analysis. Using Power BI's pivot functionality, you can transform the rows containing individual product categories into separate columns. This pivot operation enables you to present the sales data in a more concise and structured manner, making it easier to identify trends, top-selling products, and performance within each category. You've been introduced to Power BI's unpivot and pivot operations to transform and structure your data. As with other data transformation techniques, reshaping the data can help your team gain deeper insights and support business success through data-driven strategies, decisions, and actions. Now, let's take a moment to work through a practical application of the unpivot and pivot operations to the AdventureWorks sales data using Power Query in Power BI Desktop. Suppose AdventureWorks uses two separate Excel files to assess their quarterly sales and product and category distributions. The first Excel file contains the sales target data, consisting of 3 columns: month, 2022, and 2023. Within this file, there are 12 rows representing each month, and each row displays the target sales amount for the corresponding month and year. To enhance the table structure for easier readability, your manager asks you to perform an unpivot operation to create a table with columns for month, year, and target, which will also increase the number of rows. The second Excel file includes category and subcategory data, showcasing the category and subcategory data as columns without the product names. You are tasked with performing a pivot operation on this file to present the product count per category in a tabular format. To address the tasks given to you by your manager, you can start by downloading and importing the 2 Excel files into Power Query. With each data source selected, select the Transform Data option to open the Power Query editor, where you can apply various transformations, including the unpivoting and pivoting operations. For the first Excel file containing the sales target data, you need to perform an unpivot operation. To unpivot the table columns, select Target Query on the left menu. Highlight the 2022 and 2023 columns, select the Transform Ribbon tab in Power Query, and then select Unpivot. Rename the attribute column to Year and the value column to Target Amount. You now have an unpivoted table where the columns are converted to rows. To accomplish the second task and pivot the table columns in the Excel file with the product categories and subcategories, select the Product Categories query on the left menu. On the Transform Ribbon tab, select Pivot Column. Then, on the Pivot Column window that displays, select the column subcategory from the Values column list. Expand the advanced options and select the option Count All from the Aggregate Value function list. Lastly, select OK. With the Pivot Column feature applied, you change the way that the data is organized. Subcategory names are converted to columns, and row count for each subcategory is added as a row value for each column. In this video, you explored unpivot and pivot operations in Power BI and the application of both in practice. By building your technical expertise and learning about effective data transformation techniques like unpivoting and pivoting, you can maximize the potential of Power BI to unlock valuable insights from business data, ultimately contributing to growth and success of organizations like AdventureWorks. You're making good progress in your journey to becoming a data analyst. You've learned how to transform data by using Power Query and have worked on data sets. Now it's time to learn how to combine different data sources so you can use it more effectively. The capability to combine queries is valuable as it empowers you to combine and merge diverse tables or queries, enhancing your data analysis capabilities. In the next few minutes, you will be introduced to why combining data may be necessary and how you can combine tables or queries. AdventureWorks have recently acquired another bicycle business. AdventureWorks CEO, Jamie Lee, has assigned a task to the sales department to ensure that sales data from this business is incorporated in the AdventureWorks sales reports. Your manager, Adio Quinn, has tasked you with creating a Power BI query that merges the data. But before you start working on the data, you first need to understand the reasons why it is important to combine data. The first reason for combining data is that it allows you to consolidate information from various sources or tables into a single table. This consolidation can provide a unified view of the data, making it easier to analyze and gain insights. The next reason why you would combine tables is to create relationships. Combining tables is crucial for establishing relationships between related data. In Power BI, relationships between tables are used to create meaningful visualizations and enable interactive analysis. By combining tables, you can link data points across different tables based on common fields or keys. Combining tables also enables you to enrich your data by adding additional information. For example, you may have a table with client details and another table with product information. By combining these tables, you can create a comprehensive data set that includes both client and product details, allowing for a more comprehensive analysis. Another reason to combine data is that it provides a broader scope for analysis. By merging multiple tables, you gain deeper insights by analyzing data from different angles. And lastly, combining tables helps simplify data management in Power BI. Instead of working with multiple separate tables, having a single consolidated table reduces complexity and makes it easier to handle data updates, refreshes, and maintenance tasks. Now that you understand the reasons why it is important to combine data, let's look at the ways to do it. In Power BI, there are 2 ways to combine data: append and merge. When you append queries, you are adding rows of one table or query to another table or query. By adding multiple lists one below the other, you will see an increase in the number of rows. Say, for instance, you have two separate classes, Class A and Class B, that need to take an exam together. To do this, you have to combine the 20 students in Class A with the 20 students in Class B, resulting in a combined class list of 40 students. On the other hand, when merging queries, you consolidate data from multiple tables into a single entity by leveraging a shared column between the tables. For example, data with specific content such as gender, category, and city is stored in different independent tables and referenced by main tables that require this information. This allows you to use this information within a specific context, enables easy data classification, and ensures data integrity. You will learn more about both of these operations over the coming lessons. In this video, you learned about data combination techniques and the reasons for using it. Combining data in Power BI is essential for creating accurate, comprehensive, and interactive reports and visualizations. It allows you to leverage the full potential of your data by consolidating relevant information from multiple sources, establishing relationships, and enabling more insightful analysis. Good job. AdventureWorks has recently acquired an additional bicycle business. Your manager, Adi O'Quinn, tasked you with creating a Power BI query that merges the current sales data of AdventureWorks with the sales data from the newly acquired business. And he needs the query by the end of the day. But you do not panic. You know that Power BI can help you combine different tables and queries to consolidate information, create relationships, enrich data, enhance analysis, and simplify data management. In the next few minutes, you will learn why appending tables or queries may be required. At the end of this video, you will also be able to describe the operation of appending one table to another. By now, you know that there are two ways to combine data in Power BI: append and merge. When merging queries, you consolidate data from multiple tables into a single entity by leveraging a shared column between the tables. You will learn more about merging in the coming lessons. When you append queries or tables, you add rows from one or more tables to another query or table. In this video, you will focus on append. Before I demonstrate how the append operation is done, let me share a very important tip with you. Say your manager has asked you to list the AdventureWorks products that have fewer than 100 units sold for the current year. The products that have not been sold do not appear in the sales table, so you have to identify them by subtracting the sold products from all the products. As a result, you have two data sets to be merged: products with 100 or fewer sales and products that have never been sold. If you only list the products with sales data of less than 100, you won't include the products that haven't been sold at all. To overcome this problem, you have to merge the products with total sales below 100 and the ones that haven't been sold at all to present the complete picture. Back to the task Adio set you. Before you append the AdventureWorks sales.xlsx and the other sales.xlsx files, you have to format the data of both files to ensure they have an equal number of columns and that the columns have the same names and data types. If you don't have an equal number of columns or different column names, the extra columns will be added to the most right of the query by preserving their values in the originating query and setting null values for the matching new query. In this example, columns A and B are common columns in both data sets. Columns C and D are unique and added to the right of the merged list. Since the D column does not have any data in the first data set, the row values will be null after the merge. Similarly, in the second data set, null values will be added for the previously non-existent C column. This may be confusing, so try to have an equal number of columns with the same column titles. Let's explore how this is done. To format tables, select Other Sales Query in the Query pane at the left menu of the Power Query window. Rename the quantity column to Order QTY, Name to Product Name, and Total to Line Total by selecting the column names. Once you have completed the reformatting process, you can merge the queries. On the Power Query Editor ribbon, navigate to the Home ribbon tab and select the Append Queries drop-down menu. You can select Append Queries as New to create a new query or table from the appended output, or select Append Queries to merge the rows from an existing table into another. If you select Append Queries as New, you will create a new master table. This selection displays the Append window where you can select the tables you want to combine from the Available Tables section and add them to the Tables to Append section. When you select OK, a master table is created that contains the sales data of both AdventureWorks and the newly acquired company. In this video, you learned how to combine data by appending tables and queries. By appending different sales data, you can create a master sales table. This will help you to consolidate and enrich data from multiple tables and queries and simplify data management. Combining or joining data from different sources is like putting puzzle pieces together to form a big picture. The big picture can help you discover details you could have missed when examining the individual pieces. In this video, you will discover what a join is and explore the purpose of joining data and its importance in data analysis. Before we explore the power of joining data to unlock new perspectives, you need to understand what a join is. When you have data in two tables, and the columns of those tables are exactly the same, appending the data from one table to another is straightforward. However, to combine the data of two tables with different column structures, you need to specify the method in which the two tables should be combined. This is known as a join. Join is when you merge or combine data from different places to create a bigger and a more complete data set. It helps you view all the information in one place, like putting puzzle pieces together to understand the whole picture. Let's look at an example. Your manager, Adio Quinn, has tasked you to list all products with their category names and indicate which category has the most products. During your investigation, you notice that category data is referenced to a table called Categories. It is also being used by the common columns named Category Key. On closer inspection, you notice the row with a category key of 1 has a category name of Bikes, and the row with a category key of 2 has a category name of Accessories. Your conclusion is that any row with the value of 1 in the category key column has Bikes as the product's category. One of the key usage areas of joins is merging the two tables in this manner and matching related data by using the relationship. One of the key usage areas of joins is merging two or more tables and matching related data by using the relationship. Joining data is essential for Power BI data analysts because it enables you to combine information from different sources, giving you a complete picture of the data. Joining data can help you validate data accuracy, make informed decisions, and perform advanced analysis. Joining data also empowers you to gain a holistic understanding, uncover valuable insights, and make data-driven conclusions. Overall, Join is a powerful technique that enhances your data analysis capabilities and allows you to unlock the full potential of your data. In a previous video, you learned that there are two ways to combine data in Power BI: append and merge. In both merge and append operations, the use of join is essential for combining tables effectively. Let's explore merge with join in more detail. When you merge queries, you're combining the data from multiple tables into one, based on a column that is common between the tables. Merge with join allows you to match related data, integrate data, and explore relationships. When you append queries, you are adding rows of data to another table or query. Append with join helps you to ensure consistency and allow you to expand your existing data set. Whether it's a merge or append operation, the use of join is essential for aligning, integrating, and combining data from different tables. It ensures that the relevant information is properly matched and merged, enabling you to analyze and understand the data in a meaningful way. In this video, you learned what a join is, as well as the purpose of joining data and its importance in data analysis. By now, you are aware that combining data and using join keys can save you hours of searching through vast amounts of data for a specific product item. But did you know that you can simplify your query even further by specifying how the data should be combined? In this video, you will learn about join types, specifically the difference between left outer, right outer, full outer, and inner joins. A join type in Microsoft Power BI refers to how tables of data are related to each other in the software. The joins are important because they determine how data is consolidated from multiple sources into a single view. Understanding join types and their implications is crucial to building accurate, efficient, and meaningful data models in Power BI. Over the next few minutes, you'll be introduced to 4 different join types: left outer, right outer, full outer, and inner join. Let's explore each join type and the way it combines data from multiple tables based on matching criteria. Let's say we have 2 tables, one on the left for sales and one on the right for countries. The sales table has 3 columns: date, country ID, and units. The countries table has 2 columns: ID and country. The sales table country ID column can be used as a join key with the ID column of the countries table. Now let's explore each join type and how they combine data. First, let's start with a left outer join. If a left outer join is used, all rows in the left table are kept and the matching rows from the right table are merged in. If the left table is missing columns that the right table has, the columns are included as part of the merge. It is important to note that if there is no match for a row between the tables, default or null values will be used for columns where matching data is unavailable. In this scenario, the resulting table will have the columns from the left table: date, country ID, and units, along with a country name column. Since the right table did not have a country ID of 4, the country name is null. A right outer join works similarly to the left outer join, except that all rows in the right table are kept and the matching rows from the left table are merged in. Again, if the right table is missing columns that the left table has, the columns are included as part of the merge. Similarly, if there is no match for a row between the tables, default or null values will be used for columns where no matching data is available. In our scenario, the resulting table will have date, country ID, units, and country name. The full outer join is used when you want to retrieve all records from both tables, regardless of whether they have matching values in the join condition. In this scenario, since the right table has an ID of 4, and the left table does not have a corresponding entry with a country ID of 4, a row is created with a country name for ID 4 and with null values in all other columns. In the previous video, What is a Join?, you used full outer joins and append with joins by matching related data. For inner join, only matching rows from both left and right tables are merged together. This join type is helpful when you want to focus only on the sales that have corresponding data in another table and exclude any sales data that don't match. As a data analyst, you often come across the requirement to combine data from different tables or data sets related to sales and product tables. This is where merging operations, specifically join types, become crucial. Keep in mind that you should choose the combination types based on how you choose them, taking into account the specific needs of the analysis. The choice of join type will impact the inclusiveness of the data in your analysis. It's important to consider your analysis objectives and the specific requirements of your project. Each join type serves a different purpose, and selecting the appropriate one ensures that you obtain the desired result set for your analysis of order and order details data. As you start working with more and more data sources, keeping all the different data in different tables will become quickly unmanageable. Identifying similar and related data that can be merged is an important skill for a data analyst. Over the next few minutes, you will learn how to identify and merge tables using joins in Power BI. In relational data, fields such as category or status are often kept in a separate table. For instance, when a new product is added, the category information is associated with an entry in a different table instead of being manually repeated in multiple rows in the product table. As you have previously learned, data from 2 different tables can be linked by join keys. This works for tables from individual and multiple data sources. However, sometimes you'll be working with a single data source, such as a database, where these relationships are already established. In these scenarios, merging the data using a join is a straightforward operation. A column in one table will act as a key to the column of another table. In databases, this is known as a foreign key relationship, and the foreign key is used as the join key. This is almost impossible for databases that have a large number of products. For example, an e-commerce business selling books or Adventure Works, who sell a large number of product variants. Selecting from defined categories or any other parametric data ensures easy classification of data and enables us to work within a consistent and comprehensive data set. Consider a scenario where you are working in the sales department of AdventureWorks, a multinational bicycle store, and you have been given a task by your manager, Adi O'Quinn, to consolidate orders and their corresponding details, currently in 2 tables, into a single table. There is a typical foreign key relationship between the order and order details tables, which is order ID. AdventureWorks provides the following details to deal with situations such as this. The orders table is created to store information such as the name of the store, the date of the purchase, the cashier's name, and so forth. Since there can be multiple individual products associated with a single order, AdventureWorks database has created a separate but related table to store these variable numbers of associated product purchases. It allows you to add new products to your current purchase by opening as many rows as needed. In this way, you develop a structure that is dynamic and flexible, saving space and time by only storing the necessary information. To truly understand the join operation, or in Power BI terms, the combine with merge operation, it is important to first understand the relationship between tables. The merging operation arises from the need to separate tables. Avoid forcibly distributing data that can be stored in a single table into separate tables. Visualize relationships such as product category, transaction status, person city, where the definition table and its rows need to be separated. In the order example, the order details can connect unique data with repeating data in a more efficient manner. Now you can complete your task. To combine the 2 tables, orders and orders details with merge, go to Home on the Power Query Editor ribbon and select Combine. Then Merge Queries drop-down menu and select Merge Queries as New. This selection opens a new window where you can select the tables that you want to merge from the drop-down list. Next, select the column that matches between the tables, which in this case is Order ID. Select Left Outer Join in the Join Kind drop-down, which displays all rows from the first table and only the matching rows from the second. After you select OK, you are directed to a new window where you can view your new merged query. Now, let's take a look at doing this in more detail in Microsoft Power BI. In this scenario, you are working in the sales department of AdventureWorks, which is a multinational bicycle manufacturer, and you have been given a task by your manager, Adi O'Quinn, to consolidate orders and their corresponding details, which are currently in 2 tables, into a single table. In Power BI, you select the Excel Workbook option in the Data group of the Home tab. Select Order.xlsx and OrderDetails.xlsx. There is a typical foreign key relationship between the orders and order details tables. Let's try to understand this with an example from our own social life. We have all probably shopped at a market at least a few times. At the end of the shopping, we go to the cashier, scan our items, make the payment, and receive a receipt. The receipt contains information such as the name of the store, the date of the purchase, the cashier's name, and various other details. At the bottom of the receipt, there is a section that lists the quantity, unit price, and total amount for each item purchased, followed by a grand total or the amount paid. Now, let's explore how we can structure these commonly encountered pieces of information into a table format. AdventureWorks provides the following details to deal with these situations. The order table is created to store information such as the name of the store, the date of the purchase, and other details found on the receipt in our earlier market scenario. Since there can be multiple individual products associated with a single order, AdventureWorks database have created a separate but related table to store these variable numbers of associated product purchases. It allows you to add new products to your current purchase by opening as many rows as needed. In this way, you develop a structure that is dynamic and flexible, saving space and time by only storing the necessary information. To truly understand the join operation, or in Power BI terms, the combine with merge operation, it is important to first understand the relationship between tables. If there is a need to separate tables, the merging operation arises from that need. Avoid forcibly distributing data that can be stored in a single table into separate tables. Visualize relationships such as product category, transaction status, person city, where the definition table and its rows needed to be separated. Now, in the example of order details that we have learned, you have connected unique data with repeating data in a more efficient manner. Now you complete your task. To combine the two tables, order details with merge, go to Home on the Power Query Editor ribbon and select Combine. Then the Merge Queries drop-down menu, where you can select Merge Queries as New. This selection will open a new window where you can choose the tables that you want to merge from the drop-down list, and then select the column that is matching between the tables, which in this case is Order ID. You will choose to use a left outer join in the Join Kind drop-down, which displays all rows from the first table and only the matching rows from the second. After you click OK, you will be routed to a new window where you can view your new merged query. And that concludes how to combine tables with merge in Power BI. In this video, you learned how to combine data by merging tables and queries. It can help you to consolidate information from multiple tables and queries by using related fields with foreign keys. Good job. AdventureWorks is looking to expand its business by identifying new product lines that it can market to its customers. It hopes that the results of data analysis will identify potential new product lines. Meet Daniel. He's a talented data analyst with AdventureWorks. They're in-house expert at configuring and transforming data in Power BI, including merging data in Power Query. AdventureWorks has noticed that a lot of customers have been returning bicycles to their stores for repair and maintenance. These are often very simple repair and maintenance tasks, like replacing tires or tightening loose bolts and screws. The company suggests that Daniel analyzes the customer and sales data related to these transactions. Perhaps these customers might be willing to purchase a service plan for their bicycles. First, Daniel identifies the relevant data sources. He begins with an Excel sheet named Sales Data. This worksheet contains data on each bicycle AdventureWorks has recently sold, including the categories they belong to, a description of each bike, the prices they sold for, and the staff who sold them. The worksheet also includes data on the repairs carried out on each bike, like the names of the parts that were replaced. There are other relevant data sets available on a sheet named Customer Data. This worksheet provides information on all customers, including their names, contact details, age, the bikes they have purchased, and the repairs they have requested. Daniel uploads these data sources to Power BI, where he configures them for data analysis by transforming the data sets in Power Query. Once the data has been configured and transformed, Daniel then uses joins to merge these worksheets together to identify what kind of bicycles customers are buying, which customers are sending their bicycles to the store for repair, and what kind of repairs are required. He uses the results of his analysis to segment customers into profiles that focus on data such as age groups, location, and purchases. He then identifies related search engine queries for individuals who match these profiles. Through combining and analyzing this data, Daniel discovers that many of the customers seeking repairs are adults between the ages of 18 and 35 who live in rural areas. This demographic mostly purchases mountain bikes, which they use for weekend biking excursions. He presents his data insights to AdventureWorks. The company realizes that it can offer these customers a service plan or bicycle health check. In addition, existing store staff can carry out these repairs, so no new staff are needed to deliver this product. It also helps the business to retain and generate a new revenue stream from existing customers. This scenario emphasizes the importance of combining or merging data sources in Microsoft Power BI. By combining data sets, you can deliver new insights on topics. In the case of AdventureWorks, Daniel was able to create a customer profile and identify the needs of that profile. AdventureWorks then provided a new product to this customer profile. When it comes to generating data insights, the benefits of merging data sources can't be overstated. The more data you have on your topic, the greater an understanding you can develop. And all of this can be achieved with Microsoft Power BI and a strong data analytics skill set. Congratulations on reaching the end of the third week in this course on extracting, transforming, and loading data in Power BI. You've now reached the end of this module. Let's take a few minutes to recap what you've learned. You began this module by exploring the process of transforming data in Power BI. You first examined why data needs to be transformed. You learned that raw data is not always gathered or sourced in a condition that's suitable to work with. It might be incomplete, inconsistent, or have other errors. So it's important that you transform and clean your data. You can clean data by setting up filters in Power BI that identify and resolve errors. This way, the filtered data is accurate, consistent, structured, and easier to analyze. You then reviewed Power Query and its interface. You learned how to navigate this interface and locate useful tools and features for connecting, cleaning, and transforming data from a wide range of sources. And you explored the steps for these actions by helping AdventureWorks connect to its data sources and then clean and transform the data they contained. An important part of this cleaning process includes the applied steps list, an editable list of all transformations applied to a selected query. You can use this list to undo and reorder steps in the process. Next, you explored the different data types in Power BI. The data types you explored included number types, data and time type, text, or true or false, and binary. You learned that these different data types are used to classify values to help you better organize and structure your data sets. You also learned that when working with data sets, you might need to remove and rename columns. You were presented with many of the benefits of reworking columns, like more efficient, readable, and enhanced data and analysis or significant time and resource savings. You continue to explore Power Query by reviewing steps for dealing with common errors. Power Query can fix errors like null values, duplicate rows, and inconsistent data types. It's important to resolve these errors before analyzing your data in Power Query. You then made use of your new knowledge by helping AdventureWorks to prepare a data set by cleaning the data and resolving its errors. You then undertook a knowledge check. In this item, you proved your understanding of the concepts you encountered by answering a series of questions. Finally, you explored a list of additional resources designed to help you improve your knowledge of the topics that you covered this week. In the second week of this module, you explored advanced data transformation methods in Power BI. You began this week by learning about the importance of data combination, combine information, create relationships between tables, improve data and analysis, and simplify data management. You then reviewed the two main methods for combining data in Power BI, which are append and merge. Append means to add one table row or query to another. Merge means consolidating data from multiple data sources into a single table. And you examined the process for combining tables with append in Power Query Editor. You then put your new skills to use by assisting AdventureWorks with appending tables in their database. Next, you completed a knowledge check which tested your understanding of these concepts through a series of questions. And you were presented with a list of additional resources that you could review to learn more about advanced data transformation. In week 3, you learned about methods for combining data that you could use for data transformation. You discovered that one method of combining data is to use a join. A join is a useful way of combining data from different sources. You also learned that join keys are the values used to link rows between tables. You also learned that there are different types of joins. These different types include the left outer join, right outer join, full outer join, and inner join. Which of these join types you choose to use depends on your data transformation needs. You then looked at how to combine tables using a merge operation in Power Query Editor. By identifying the relevant keys and required join operations, you can merge 2 or more tables to deliver new insights into your data. Next, you demonstrated your competence with these new skills by helping AdventureWorks to merge 2 of their data sources to deliver new insights into their business. Finally, you undertook a knowledge check, which tested your understanding of the concepts that you encountered this week. And you completed a module quiz, in which you demonstrated your understanding of all concepts you encountered throughout the entire module. You've learned a lot about transforming data in Power BI, and as you approach the next module, consider going through some of the learning material again to reinforce your understanding. Looking ahead, you will expand your knowledge of the ETL process by diving into advanced ETL in Power BI, where you will learn all about loading and profiling data and advanced queries. Best of luck. You have gained detailed knowledge about the extract and transform steps in the ETL process so far, and you have applied this knowledge by considering scenarios and tasks. In this video, you will learn about the final step of the ETL process, load. The load operation, in summary, enables the transformed data obtained by reading from a data source to become available for reporting purposes. Considering that the ultimate goal of Power BI is to provide data visualization through reports and dashboards, the importance of making the data available for this purpose becomes evident. Up until the load stage, you have completed tasks such as accessing data sources, establishing connections, extracting data, and performing transform operations. The purpose of all these operations was to bring meaningful and cohesive data into the reporting interface, filtered based on specific criteria. The load process ensures the visualization of all the extracted and transformed data. There are two main ways to load data in the Power BI user interface: load and transform data. Let's look at each option a bit closer, starting with load. With the load option, data is loaded directly into the data pane in Power BI. If you choose to load data directly, you can still transform the data at a later stage. The second option, transform data, allows you to transform the data before loading it. The changes to the data are applied to the data model, and the data pane is refreshed in Power BI. Visualizations can now use the applied changes. Whether you choose to load the data directly with the load option or transform the data before loading with the transform data option, loading time can vary depending on the size of your data set. Optimizing performance and reflecting updated data from the source in reporting are of great importance in the data loading process. In the upcoming sections, you will gain detailed information about these topics. In some cases, you might have some source tables which are used during the ETL process that will not be used directly in the reporting area. And some of these tables may not meet the production demands of your data warehouse. In such cases, you will need an intermediate state between the data source and the data warehouse, called the data staging area. A staging area serves as an intermediate storage location for raw or unprocessed data, allowing it to be temporarily stored and prepared for further processing in a data pipeline. The existence of a data staging area is not obligatory for your ETL jobs, so you can execute ETL jobs without creating staging areas. However, it is recommended to simplify the process of data cleansing and consolidating data coming from multiple sources. By now you know that the data loading process is the final step of the ETL operation and that it is the most crucial step for making the data available in the reporting environment. To achieve this, the data is loaded into Power Query either directly from the data source or after performing transformation operations. Additionally, a staging area is often used as an intermediate step to store the data in a more organized manner, aiming to facilitate maintenance and management tasks. By completing the load stage, you are now ready to explore the data, create compelling visualizations, and gain valuable insights to support decision-making for your organization. Data staging is one of the key concepts in data loading. Over the next few minutes, you will learn the basics of data staging, the reasons for its necessity, and the advantages of using it in the overall ETL processes. To better understand the concept of staging, let's use an everyday life example. Imagine you've invited friends over for dinner, and you've bought ingredients from the grocery store to prepare the meal. However, you don't serve the ingredients as they are. You might marinate the meat in a pot, cut the vegetables, and place them in a bowl for washing, and prepare other dishes like making a salad or putting appetizers on a plate. In this example, all the ingredients represent raw data, while the processes of marinating, washing, cutting, and weighting correspond to ETL operations. The pots, bowls, and other utensils used before serving can be thought of as the staging area. Now let's apply this everyday life example to data staging. A staging area serves as an intermediate storage location for raw or unprocessed data, allowing it to be temporarily stored and prepared for further processing. The staging area typically acts as a bridge between the data sources and the data warehouse. A staging area simplifies the process of data cleansing and consolidation of operational data originating from multiple source systems, particularly for enterprise data warehouses that centralize an organization's critical data. Remember, a data staging area is not required for your ETL jobs. You can still execute ETL jobs without creating one. However, based on your need to consolidate data coming from multiple sources, it is recommended. Over at AdventureWorks, the company receives feedback about its products from various channels, such as social media platforms and corporate websites. Your manager, Adio Quinn, has tasked you to prepare a data set by using these resources to consolidate and to prepare the data for use in reports and dashboards. None of the feedback can be used in its raw form, as they have different formats. You must transform the data and then consolidate it in a unified list. Since you will only use this data in the ETL process, it is appropriate to use a staging area. Let's take a few moments to complete this task using Power Query. The first step is to import the two datasets, AdventureWorks Social Media Feedbacks 1 and AdventureWorks Social Media Feedbacks 2, to transform and consolidate in the staging area. To do this, navigate to the Home ribbon tab at the top of the Power BI window. Select the Excel Workbook button inside the data group in the middle of the toolbar. Select your datasets and select Open. Then select your datasets and select Transform Data in the window that opened. Now you have two queries, AdventureWorks Social Media Feedbacks 1 and AdventureWorks Social Media Feedbacks 2 in the Queries pane at the left menu of Power Query. To successfully complete your task, you have to consolidate these two queries into a single query and add an extra column to indicate where the feedback came from. To do this, you have to use these queries and integrate the data into a more defined and optimized model. To do this, you need a staging area. As you have to consolidate these two tables into one, but also keep them separately, you have to create a new group called the staging area. In the Queries pane, at the left menu of Power Query, select New Group. Type Staging Area in the Name text box and select OK. Now, move both the datasets AdventureWorks Social Media Feedbacks 1 and AdventureWorks Social Media Feedbacks 2 to the Staging Queries group. Your tables are now organized according to your need. Select the AdventureWorks Social Media Feedbacks 1 and AdventureWorks Social Media Feedbacks 2 tables respectively and disable the load by clearing the checkbox Enable Load. You will keep the Include in Report Refresh option. This way, both tables will still be used in queries but will not be part of the data model. You are now familiar with the concept of a staging area and how it is implemented in Power BI. Imagine you have just started working at AdventureWorks as a data analyst. You have a lot of data to analyze to determine which products are preferred by which client and why. To perform successful analysis on these many items, it is necessary to have data that includes fields suitable for analysis, with an adequate amount of data and a variety of data ranges, representing the overall data. Over the next few minutes, you will be introduced to data profiling and statistical analysis and why it is important when reviewing data sets. By the end of this video, you will have been introduced to a high-level understanding of data profiling and statistical analysis when reviewing data sets. You will also learn about the distribution, anomalies, and outliers in the context of data profiling. Let's first cover an introduction to data profiling. Before analyzing any data set, it is important to examine and evaluate the data you are working with. Analyzing the data without evaluating its accuracy, completeness, and alignment with the objectives can lead to misleading results. When examining a data set for the first time, there are several aspects you should look at, especially for numerical fields. You should check these characteristics for each numerical field: minimum or min, maximum or max, average or mean, frequently occurring values or mode, and standard deviation. The best way to start assessing data is with data you can immediately troubleshoot. Imagine you are reviewing a dataset that has an age field. For instance, there could be someone in the dataset with an age of 200, which would be extremely unlikely to be true. If so, there may be an outlier in the data. Look at the minimum and maximum values, such as appearing between 21 and 77. These are realistic ages, unlike 200. The concept of distribution of data refers to how the data points are spread or arranged within a dataset. It describes the pattern or shape of the data when plotted on a graph. Understanding the distribution of data is crucial in data analysis because it helps you gain insights into the central tendency, variability, and overall characteristics of the data. Next, let's consider outliers. The formal definition of an outlier in statistics is a data point that significantly deviates from other observations. Outlier data can be handled by applying a technique called min-max scaling, or normalization. The aim is to adjust the mean and standard deviation of the data proportionally while preserving the ratio of the distance between outlier data and other data points. Analyzing the distribution allows you to make informed decisions, identify outliers, and choose appropriate statistical techniques for further analysis. There are situations where there may be values in the data set that skew the average. For example, there may be examples close in age. Let's say there are 3 individuals aged 80 and above. If you solely rely on the average to evaluate the distribution, these outliers can mislead you by increasing the average. In this case, it would be appropriate to examine the distribution more closely. When taking a closer look at the data, you may find that the distribution is normal, but the 3 records mentioned in the example are outliers. Next, let's look at standard deviation. Standard deviation is a statistical measure that quantifies the amount of variation or dispersion in a data set. It provides a way to understand how individual data points differ from the mean or average of the data set. The main objective here is to prevent outliers from causing deviations in your analysis results, minimizing their impact. Finally, let's return to the point of distribution of data. The balanced distribution of data points that fall outside the outliers is another factor that affects data quality and your analysis results. It is important for descriptive variables such as age, gender, income status, occupation, city, and neighborhood to represent as many diverse groups as possible and be evenly distributed among others. If not, a cluster of records that closely resemble each other will lead to narrow intervals when defining norms, which will mislead your analysis. Profiling and statistically analyzing data, including examining its distribution, min, max, mean, and mode values, detecting outliers, if any, and normalizing outliers, ensuring that the data represents the entirety of the data set, are the key elements that demonstrate data quality. Considering these factors will enhance the accuracy and quality of analysis and predictions made with this data. By now, you should have a good understanding of the concepts of profiling data and possible situations where you will need to apply the profiling techniques. In this video, you will learn about data profiling and statistical analysis and how to use them in Power BI. As well as this, you will cover how to use profiling tools to inspect the data. AdventureWorks recently conducted a field survey to increase sales and collected potential customer data. This resulted in an Excel file containing information such as age, gender, occupation, income level, address, and phone number of prospective customers. Since the survey data was collected manually, it was not subjected to any validation. Therefore, before analyzing the data, it is necessary to confirm that the data is valid, within the desired ranges and quantities, and exhibits a good distribution. Before starting analysis on any data set, it is important to examine the data. By examining various aspects such as completeness, accuracy, uniqueness, and consistency, data profiling enables the identification of potential issues and anomalies within the data set. This proactive approach allows you to make informed decisions about data cleaning, transformation, and enrichment, ultimately leading to improved data quality. Additionally, data profiling facilitates effective data exploration and visualization by providing insights into data patterns, relationships, and trends. It empowers users to discover hidden insights, uncover data inconsistencies, and make data-driven decisions with confidence. Before delving into data profiling tools, let's first consider two important factors in data profiling: unique and distinct. In Power BI, unique is known as total number of values that only appear once. Distinct is known as total number of different values, regardless of how many of each you have. Microsoft Power BI offers the following two profiling tools in the Power Query editor: column quality and column distribution. Let's begin with column quality. Column quality focuses on valid, error, and empty rows on each column, allowing you to validate your row values. The column quality feature labels values in rows in 5 categories: valid, shown in green; error, shown in red; empty, shown in dark gray; unknown, shown in dashed green. Indicates when there are errors in a column, the quality of the remaining data is unknown. Unexpected error, shown in dashed red. These indicators are displayed directly underneath the name of the column as part of a small bar chart. The number of records in each column quality category is also displayed as a percentage. By hovering over any of the columns, you are presented with a numerical distribution of the quality of values throughout the column. Additionally, selecting the ellipses button opens some quick action buttons for operations on the values. Column distribution provides a set of visuals underneath the names of the columns that showcase the frequency and distribution of the values in each of the columns. The data in these visualizations is sorted in descending order from the value with the highest frequency. By hovering over the distribution data in any of the columns, you get information about the overall data in the column with distinct count and unique values. You can also select the ellipses button and choose from a menu of available operations. Let's consider column distribution, specifically relating to distribution of distinct and unique amounts. Imagine that you have a selection of bike accessories that are supplied by 4 different suppliers: Supplier A, Supplier B, Supplier C, and Supplier D. In this case, there are 4 distinct suppliers. Now imagine you have 2 bikes, each with a unique supplier to any other bikes you currently stock. These would be considered 2 unique suppliers. Another type of profiling in Power BI is column profile. Column profile provides column statistics such as minimum, maximum, average, frequently occurring values, and standard deviation, and in addition, value distribution on the selected column. This is very important when assessing data to detect anomalies and outliers. Now that you've covered the basics of data profiling tools, let's apply this in Power BI and inspect some data. AdventureWorks conducted a field survey to increase sales and collected potential customer data. This survey resulted in an Excel file containing information such as age, gender, occupation, income level, address, and phone number of prospective customers. The survey data was collected manually. It was not subjected to any validation. Therefore, before analyzing the data, it is necessary to confirm that the data is valid, within the desired ranges and quantities, and exhibits a good distribution. Navigate to Home at the top of the Power BI window. Select Excel Workbook inside the data group in the middle of the tab. Select Potential Customers.xlsx and select Transform Data in the opened window. Check the Column Quality checkbox inside the Data Preview group of View to assess column quality. In the Age column, 89% of the values are valid, 0% of the values are error, and 11% of the values are empty rows. To assess column distribution for the Occupation column, on the View tab from inside the Data Preview group, check Column Distribution. Note that there are 9 distinct values and 2 unique values. Computer programmer and accountant are the occupations which appear only once. For each column, note that if all the row values are distinct, then unique and distinct amounts will be equal. For example, you can see that there are 19 distinct and 19 unique values for the surname column. Select the age column and then check the column profile checkbox. Note that maximum value for age column is 132, which is not acceptable. Examine the minimum, maximum, average, and other column statistics and review the value distribution chart. In this video, you learned how to profile data by assessing column quality, distribution, and profile. Data profiling in Power BI offers several advantages in the process of data analysis. It helps you gain a comprehensive understanding of the data quality, structure, and distribution. With its ability to assess data quality and provide valuable insights, data profiling in Power BI plays a crucial role in enhancing data reliability, accuracy, and overall analytical outcomes. In the world of technology, even the most meticulously designed software can harbor hidden bugs waiting to unleash chaos upon unsuspecting users. Imagine a scenario where a simple bug managed to infiltrate a company's database, threatening to compromise the accuracy of critical reports and potentially sending shockwaves through senior management. However, thanks to the miraculous powers of data profiling, with the aid of Power BI, disaster was averted and the company emerged victorious. Buckle up as we take you on a thrilling journey through the realm of software mishaps, triumphs, and the heroes who saved the day. It all began innocently enough. Deep within the complex coding of a company's flagship software, a tiny bug had nestled its way into the system. This bug had an uncanny ability to transform innocent data into deceptive monsters, causing them to wreak havoc when unleashed into the wild. The bug was sly and patient, biding its time until the perfect moment to strike. As the software went about its daily operations, the bug began silently distorting the data it touched. Unbeknownst to the users, inaccuracies were creeping into the system, lurking beneath the surface. Reports that were once reliable now became unreliable, leading to questionable decisions and raised eyebrows among senior management. Fortunately, the company had an ace up its sleeve, a team of brilliant data profilers armed with the mighty Power BI. With its robust data profiling capabilities, Power BI became the ultimate weapon against the deceptive bug and its corrupted data. The team rallied together, ready to utilize Power BI's analytical prowess and visualizations to uncover the truth hidden within the tainted database. Armed with Power BI, the heroic team embarked on a quest to hunt down and eradicate the corrupted data. They connected Power BI to the company's database, leveraging its intuitive interface and advanced algorithms to identify the anomalies lurking within the system. Power BI's data profiling features allowed the team to analyze and scrutinize every nook and cranny of the company's data, unearthing the bug's footprints one by one. After days of tireless work, the data profilers empowered by Power BI emerged triumphant. They successfully identified and isolated the distorted data, ensuring its exclusion from future reports. Power BI's rich visualizations and interactive dashboards enabled the team to present their findings to senior management in a clear and concise manner, further solidifying their victory. As the dust settled, the company took a moment to reflect on the incident. They recognized the transformative power of Power BI's data profiling capabilities and the critical role it played in safeguarding their data integrity. The bug had served as a wake-up call, reminding them of the importance of incorporating robust data profiling tools like Power BI into their systems, helping them catch potential issues before they cascade into crisis. In this thrilling tale of software mishaps and heroic data profilers, we've witnessed how a simple bug had the potential to plunge a company into chaos. However, thanks to the power of data profiling, with the aid of Power BI, accuracy was restored. The diligent efforts of the data profiling team did not go unnoticed as senior management praised them for their exceptional work and dedication in resolving the crisis. The successful outcome served as a reminder of the invaluable role data profiling plays in maintaining the integrity of systems. It showcased the power of collaboration, expertise, and the remarkable capabilities of tools like Power BI in conquering challenges and emerging triumphant. As a data analyst at AdventureWorks, your team is responsible for analyzing vast amounts of data to gain insights into customer behavior and improve business operations. Microsoft Power Query is an essential tool in data analysis workflow, enabling you to transform and integrate data from various sources. You heavily rely on Microsoft Power BI for your daily tasks, preparing reports for business units by connecting to data sources and performing extract, transform, and load operations. Since AdventureWorks strive for optimal efficiency and results, your manager, Adi O'Quinn, has assigned you the task to research best practices for specific configurations, performance preferences, security, and other related topics to ensure the most optimal use of Power BI in your work. Over the next few minutes, you'll be introduced to best practices when working with data sources in Power BI, and also understand why these practices are important to implement. Let's start by exploring how you and your team can apply best practices to enhance your Power Query workflows and improve data quality and analysis. Your first step is to plan and document your data transformation requirements. You define the desired output, identify the relevant data sources, and outline the transformations needed. You also ensure that data source credentials are properly documented and securely stored. By maintaining an organized and consistent approach, your team can streamline your Power Query process and avoid confusion. Next, you carefully select the appropriate connector to connect to your data sources. You consider factors such as the type and location of the data source, the volume of data, and the available connectivity options. With Power BI's wide range of connectors, you can seamlessly connect to databases, cloud services, files, and APIs. It is important that you evaluate the performance capabilities and scalability of the connectors to ensure optimal performance for your data requirements. Considering the performance and optimization of your data transformations and calculations, your team follows the principle of do expensive operations last. You prioritize and schedule resource-intensive operations towards the end of the data transformation process. This approach ensures that complex calculations, merging large data sets, and applying multiple transformations on a significant number of rows are executed efficiently, leading to faster data loading and more responsive reports. Your team also pays attention to data type selection for columns, aiming to improve performance and data accuracy. You review and adjust the inferred data types manually, preventing incorrect data interpretations and reducing memory consumption. Data profiling plays a crucial role in your team's data analysis process. You leverage Power BI's data profiling capabilities to gain a comprehensive understanding of data quality, structure, and distribution. By examining aspects such as completeness, accuracy, uniqueness, and consistency, you identify potential issues and anomalies within the data set. This proactive approach enables you to make informed decisions about data cleaning, transformation, and enrichment, ultimately improving data quality. To ensure smooth data processing, your team implements error handling techniques, such as conditional logic and custom error messages. You also incorporate data validation checks to identify and handle unexpected data inconsistencies effectively. The next best practice is to consider your merge strategy. When merging or joining multiple queries, you consider the most efficient merge strategy, selecting inner joins whenever applicable. You remove redundant fields to avoid unnecessary duplicate columns in the resulting merge query. To maintain an organized work environment, your team utilizes groups as containers for your queries. You create nested groups when needed and easily move queries between groups by dragging and dropping them. Regularly reviewing and removing unnecessary steps in the Power Query editor is another practice you follow. Removing unused or redundant transformations helps improve processing time and simplifies query maintenance. Monitoring the performance of your Power Query workflows is an ongoing task for your team. You evaluate the refresh speed, resource consumption, and overall efficiency. By fine-tuning query settings, such as parallel loading or data load options, you optimize performance based on your specific requirements. Following these best practices when working with Power Query will enable you to effectively shape and transform your data while maintaining data integrity, improving performance, and streamlining your workflows. Remember, consistent documentation, efficient data filtering, error handling, and optimization techniques are key to achieving reliable and efficient data transformations with Power Query. Embrace these practices, adapt them to your specific requirements, and continue exploring new features and capabilities to become a Power Query expert. Power Query is a powerful data transformation and manipulation tool within Power BI that allows users to shape and transform data from various sources. But performing repetitive steps on multiple queries can be a tedious task, especially when the queries involve similar but separate sets of data. One of the key features to solve this issue is through reference queries, which provide flexibility, reusability, and efficiency in your data transformation process. In this video, you will learn about reference queries in Power Query and its importance in streamlining data workflows. You'll also explore best use cases for reference queries and data flows. By establishing a query reference, you can establish a connection between an existing query and a new query, enabling data flow across sequential models. Any modifications made to the original query will automatically apply to the referenced query, ensuring consistency and up-to-date information. Instead of modifying transformations individually in multiple queries, you can make updates in the master query, and those changes will be automatically applied to all reference queries. This provides cohesion and makes it easier to maintain and update your data transformations. So what are the benefits of query referencing? Let's explore some examples. First, there is reusability. By referencing queries, you can reuse common data transformations across multiple queries. This promotes consistency in your data processing and reduces the risk of errors that can occur when duplicating complex transformations. Next, there is efficiency. Reference queries eliminate the need to repeat time-consuming data transformation steps. Instead, you can leverage the results of a previously defined query, significantly improving the performance of your data workflows. Lastly, you have scalability. As your data analysis requirements grow, reference queries allows you to build modular and scalable data transformation workflows. You can create separate queries for different data sources or transformation steps and combine them as needed, providing flexibility and adaptability to changing business needs. In Power Query, you can reference a query by using the Reference option by right-clicking any query in the Queries pane. Reference will create a new query, a copy of the original query, but containing one single step. You can rename the new query as you need and then start to use it. In this way, you establish a connection between the queries, enabling data flow and transformation continuity. Let's delve into this further through a scenario. You are working as a data analyst at AdventureWorks, which recently acquired another bicycle business. Your manager, Adi O'Quinn, has assigned you the task of appending the product data from the newly acquired company to AdventureWorks' existing products. Prior to appending the new products, you need to perform several transformation tasks, such as changing column types and removing unnecessary columns. However, your manager has asked you not to modify the existing queries to preserve their original form and use them as a source for other operations. To accomplish this, you need to create references from the original queries, rename the new queries, apply necessary transformations, and then append the data. Any changes made to the base queries will impact on the new queries. This approach allows you to keep the original queries, update the reference queries, and ensure that any changes made to the base queries are reflected in the referenced ones. Query referencing creates many opportunities for advanced data transformation techniques. You can apply conditional logic, merge referenced queries, or perform calculations based on referenced data. These advanced techniques further enhance the flexibility and power of your data workflows. Referencing queries in Power Query is a fundamental concept that allows you to streamline and optimize your data transformation process. By leveraging query references, you can improve reusability, efficiency, and scalability, ultimately enhancing the overall productivity and effectiveness of your data analysis in Power BI. As data volume continues to grow, so does the challenge of transforming that data into well-formed, actionable information. We want data that's ready for analytics to populate visuals, reports, and dashboards so we can quickly turn our volumes of data into actionable insights. However, managing and preparing data for analysis can be a complex and time-consuming process. It's important to consider the best approach for your data transformations and analysis. In this video, you will explore how to reference other queries and why a data flow may be more suitable. Choosing between referencing queries and data flows depends on the specific requirements of your scenario. It's important to evaluate factors such as data volume, complexity of transformations, user expertise, and maintenance requirements to determine the best fit for your use case. There are some performance considerations you need to bear in mind with regards to reference queries especially. Reference queries can contribute to slow data refreshes due to the nature of their referencing. When a reference query is refreshed, it needs to ensure that all the referenced queries are also refreshed to maintain data consistency. This can result in longer refresh times, especially if there are multiple layers of referencing involved. Furthermore, reference queries can overburden data sources, particularly when working with large data sets. As reference queries rely on the data from other queries, they need to fetch and process the data from the original sources. This becomes more noticeable when dealing with complex transformations or frequent refreshes. To mitigate these issues, it's important to optimize the design and usage of reference queries. Consider limiting the number of reference layers and optimizing the query's transformations to reduce unnecessary data processing. Additionally, carefully manage the refresh schedule to avoid excessive load on data sources during peak usage times. By implementing these best practices, you can help minimize the impact of reference queries on data refreshes and prevent overburdening your data sources. Now, let's review data flows. Data flows offer a centralized and scalable approach for data preparation. Data flows are designed specifically for data integration and transformation tasks, providing a self-service environment for business users to create and manage, extract, transform, and load processes, referred to as ETL processes. With data flows, you can connect to various data sources, perform transformations using a visual interface, and store the prepared data in the Power BI service. Data flows are a feature available in both Power BI Desktop and Power BI Service. Data flows provide a cloud-based data preparation experience where you can build, manage, and share reusable data entities. In summary, understanding the differences and best use cases between reference queries and data flows is essential for optimizing your data processing workflows in Power Query. Reference queries in Power Query is a fundamental concept that allows you to streamline and optimize your data transformation process. By leveraging query references, you can improve reusability, efficiency, and scalability, ultimately enhancing the overall productivity and effectiveness of your data analysis in Power BI. Remember, practice makes perfect. Experiment with reference queries in Power Query to gain hands-on experience and discover the immense value it brings to your data analysis endeavors. At AdventureWorks, you have a task that needs separate analysis for 3 main bike product categories. You soon realize that to complete the task, you're creating the same query 3 times, the only difference being the change to the bike category. It's inefficient to completely rewrite queries whenever there's a minor change in the data or a slightly different question from management. What if there was a way to create adaptable, reusable queries? There is. The Query Parameters feature in Microsoft Power BI allows you to define one query that can be easily adjusted to handle different categories or variables. This video will help you understand the concept of query parameters in Power BI. It explains how to effectively implement and manage query parameters. Let's learn how query parameters can make your data analysis tasks more efficient and adaptable. Query Parameters in Power BI is a powerful feature that allows users to input a value, which is then used in the data retrieval process from a data source. Essentially, it's a placeholder for information that can change. The query parameter can be used in various operations, such as filters, transformations, or creating new columns and tables. Let's explore some possible uses of query parameters at AdventureWorks. AdventureWorks can use query parameters when connecting to its database to retrieve specific information rather than importing the entire dataset. For instance, AdventureWorks can establish a query parameter for a sales date range. By inputting the dates, Power BI will only fetch data for that period, saving resources and time. Parameters can also be used in AdventureWorks data transformations. If there's a need to frequently adjust a specific value in the transformations, using a parameter avoids manual changes each time. The value only needs to be updated in the parameter. Parameters can control filters on AdventureWorks data. If the company wants viewers of a report to concentrate on a particular product category, they could create a parameter for the product category. This allows the viewer to select the category they're interested in, and Power BI will adjust the report accordingly. Now, let's explore creating query parameters in Microsoft Power BI. First, you'll need to open the Power Query Editor in Power BI. To do this, go to the top left corner of the Power BI desktop interface. There is a set of tabs in a ribbon layout. One of these tabs is Home. Select this Home tab. Once you are in the Home tab, select Transform Data. This action will open the Power Query Editor. In the Power Query Editor, go to the Home tab. Select the Manage Parameters option. This opens the Manage Parameters dialog box, where you can create parameters. To create a new parameter, select New. Now you are able to name your parameter and define its properties. For instance, you might name it Product Category Filter. Under Type, from the drop-down menu, select Text as the data type. Next, specify what values this parameter can take. From the Suggested Values drop-down menu, choose List of Values. In the input field that appears, create your list by entering the different product categories from your dataset. Therefore, the values here are such items as mountain bikes, road bikes, and touring bikes. Once you've filled in these details, select OK. Then OK again in the Manage Parameters dialog to return to the Power Query Editor. Query parameters can significantly enhance your Power BI reports, making them more flexible and interactive. Parameters enable efficient data retrieval and transformation by allowing for dynamic changes, helping you cater to evolving business needs without having to rewrite entire queries. The more adaptable your data analysis tools are, the more capable you become in meeting your organization's ever-changing demands. This makes your work more efficient and enables you to provide valuable insights that can guide your company's decision-making processes. Keep exploring, keep learning, and embrace the power of query parameters in Power BI to improve your analysis. In previous videos in this course, you learned about advanced query capabilities, data flows, and the differences between reference queries. As mentioned before, every instance of data transformation performed in Microsoft Power Query adds a step to the Power Query process. These steps can be rearranged, removed, or modified as needed to optimize the data shaping process. Whenever you use the Power Query interface, M language code is executed to perform each operation behind the scenes. The M language is available for you to read and modify directly in the Power Query Advanced Editor. In this video, you'll learn how to use this advanced editor to update an M query. A core capability of Power Query is to filter and combine data from one or more supported data sources. Any such data mashup is expressed using the Power Query formula language, mQuery. Although you don't have to know M language to use Power Query, being familiar with the language used behind the user interface, as well as being able to update it when necessary, is valuable for anyone using the tool. For example, you may need to perform custom transformations that cannot be easily accomplished using the Power Query user interface alone. This is where knowledge of the M language and its syntax can be helpful. Using the M language, you can perform advanced data manipulation tasks such as conditional filtering, custom column creation, data type conversions, and merging multiple data sources. The language is designed to be expressive and efficient, enabling you to handle large data sets with ease. When you access the M language code, there are certain group names and meanings that are called M syntax. Let's explore the syntax using an M language code snippet. This snippet showcases how to handle various CSV file operations in Power Query, including setting up the initial data source and performing data transformations, loading the file, specifying the delimiter and encoding for the CSV document, calculating the number of columns, and assigning a value to a variable. You can find more information on M syntax in the additional resources of this lesson. It can also serve as template code for further data transformations using the Power Query M language in Power BI, which you can customize based on your needs. The Advanced Editor provides syntax highlighting auto-completion and error checking features, making it easier to write and debug your M code. It also offers functions and operators that allow you to perform various data transformations, calculations, and aggregations. Now, let's explore how you can use the Advanced Editor tool in Power Query and modify steps by updating M language code using a practical scenario. A report designer informs Adi O'Quinn, your manager at AdventureWorks, about an error being received in the Power Query window. He assigns you the task of identifying the cause of this error and resolving it. You investigate the issue by examining the steps in Power Query and analyzing the problem using the M language, discovering that the error is a result of a change in the source file's location. Let's outline the steps to resolve this issue using the Advanced Editor tool. Let's start with the source file, an AdventureWorks sales spreadsheet in Excel. If you navigate to the Home tab at the top of the Power BI window, select Excel Workbook in the Data group, followed by the AdventureWorks sales file, and lastly, select Transform Data in the Opened window, you'll successfully access the Power Query editor. However, suppose the location of the source file is unintentionally changed by another person. For example, the Excel file is moved to another folder. This will cause an error in the Power Query window. To explore what happens as a result of this error, let's navigate to Refresh Preview in the Query group on the Home tab and select Refresh Preview from the drop-down menu. When you refresh the preview, you now get an error message indicating that the source file is no longer reachable as the location has changed. You can resolve this issue by using the Advanced Editor. To do this, you need to select Advanced Editor in the Query group on the Home tab. Next, you'll need to read the error message and code carefully to determine the necessary action. In this case, you need to correct the file path. In this scenario, I'll change the path from CData C3M3L3 AdventureWorks Sales.xlsx to CData AdventureWorks Sales.xlsx. Your file path will differ from this as it will specify the location of the file on your computer. After you've completed your correction, you can select Done in the Opened window. With this edit, you've modified the code using Advanced Editor, correcting the file path and resolving the issue. By using the Advanced Editor and familiarizing yourself with the M language, you can unlock the full potential of Power Query. Whether for error checking or creating sophisticated data transformations that meet your specific requirements, the Advanced Editor empowers you to manipulate and shape your data precisely. Congratulations on reaching the end of the third week in this course on extracting, transforming, and loading data in Power BI. You've now reached the end of this module. Let's take a few minutes to recap what you've learned. You began this module by exploring the final step of the ETL process, load. You learned that the load operation enables the transformed data obtained by reading from a data source to become available for reporting purposes. You then explored the two main ways to load data in the Power BI user interface. Load. This option directly loads data into the data pane in Power BI, and you can still transform the data at a later stage. And transform data. The option allows you to transform the data before loading it with changes being applied to the data model. Next, you discovered that in some cases, you might have some source tables which are used during the ETL process that will not be used directly in the reporting area. And some of these tables may not meet the production demands of your data warehouse. In such cases, you will need an intermediate state between the data source and the data warehouse, called the data staging area. A staging area serves as an intermediate storage location for raw or unprocessed data, allowing it to be temporarily stored and prepared for further processing in a data pipeline. You then made use of your new knowledge by helping AdventureWorks transform and consolidate data by using a staging area. Next, you undertook a knowledge check. In this item, you proved your understanding of the concepts you encountered by answering a series of questions. In the second week of this module, you were introduced to data profiling in Power BI. You began this week by learning about the importance of data profiling and statistical analysis when reviewing data sets. You also learned about distribution, anomalies, and outliers in the context of data profiling. And you learned about standard deviation. Next, you explored the two profiling tools in the Power Query editor, column quality and column distribution. You then put your new skills to use by assisting AdventureWorks with data profiling and statistical analysis, using the profiling tools in Power BI to inspect data. Next, you completed a knowledge check, which tested your understanding of these concepts through a series of questions. In week 3, you discovered the best practices when working with data sources and why these practices are important to implement. Then, you had the opportunity to complete a practical exercise, importing a data set while considering the best practices. You were then introduced to data flows. You explored what data flows are and why they are used in Power BI. You learned about the subscription level required to use them and engaged with a fictional scenario showcasing their application and the advantages and limitations they offer. Next, you explored reference queries and their importance in streamlining data flows. Reference queries in Power Query refer to the practice of using the output of one query as a data source or transformation step in another query. You then explored the performance considerations you need to bear in mind when using reference queries. Next, you demonstrated your competence with these new skills by helping AdventureWorks to merge two of their data sources, using reference queries to deliver new insights into their business. Next, you explored the Query Parameters feature in Microsoft Power BI. You learned that this feature allows you to define one query that can be easily adjusted to handle different categories or variables, and you examined the process for disabling helper queries in Power BI. After that, you were introduced to the advanced editor and learned how to modify code. You learned that whenever you use the Power Query interface, M language code is executed to perform each operation behind the scenes. And you learned that, although you don't have to know M language to use Power Query, being familiar with the language used behind the user interface as well as being able to update it when necessary is valuable for anyone using the tool. You then explored the various global options Power BI offers that allow you to customize and optimize your experience when working with files. You learned that these options provide flexibility and control over file settings, ensuring a seamless workflow and enhancing your overall productivity. Finally, you undertook a knowledge check, which tested your understanding of the concepts that you encountered this week. And you completed a module quiz in which you demonstrated your understanding of all concepts you encountered throughout the entire module. You should now be familiar with the advanced ETL processes in Power BI. You should be capable of loading data with Power BI, profiling this data, and using advanced queries in Power BI. Great work! You have almost reached the end of this course. In this video, you'll consolidate key concepts you learned throughout. You'll revisit essential learnings related to the data analysis process for businesses and transforming data into valuable insights using Power BI. Through your continuous effort, you've gained a solid foundation in collecting data from and configuring multiple data sources in Power BI, preparing and cleaning data using Microsoft Power Query, and inspecting and analyzing data to ensure data integrity. You have demonstrated tremendous dedication to this course through your engagement with the videos, readings, exercises, and quizzes. What's left now is to demonstrate the skills you've learned in the final course project. This recap will serve as valuable preparation for your final course assessment and graded quiz. In the final course assessment, you'll apply what you've learned by completing tasks that simulate a real-world data analysis scenario. To consolidate your learning, you'll then take a final graded quiz to assess the knowledge and skills you gained throughout this course. Let's get started by revisiting your first week of learning. In the first week, you learned about data sources, local and shared data sets, working with Excel data types, storage modes, triggers, and actions. You primarily focused on data sources. In the process, you covered the skills to connect data sources, choose the correct query modes, either import or direct, and setting up triggers and actions to stay updated with the frequently changing data. Week 2 began with analyzing the need behind the data transformation and getting familiar with the Power Query interface, which will be used throughout the ETL operations. You continued your journey with learning about columns, data types, applied step lists, and common data errors, and then you prepared a data set. You also learned how and why to pivot and unpivot tables, which are very popular operations. Finally, you applied combining table operations, which are appending, merging, and joining tables. These Week 2 contents are fundamentals for ETL operations. Week 3 began with loading data and staging area concepts. You applied an end-to-end ETL operation, then learned about data profiling, which is very important for understanding data quality and distribution. This helps you detect a potential anomaly in a data set before you start to analyze it. You then explored how to use M language in Advanced Editor to apply detailed operations in Power Query. Finally, you learned data flows and reference queries, which are used to increase efficiency and productivity. This course equipped you to use Power BI and Power Query to construct end-to-end ETL solutions, starting from understanding data sources, then advanced transformation techniques, and ended by loading data in Power BI. As you embark on the final course project and assessment, you can approach it with confidence, knowing that you've built a strong foundation of knowledge and skills by committing to your learning journey throughout the course. However, if you feel the need to review any of the concepts summarized for you in this video or require additional preparation, remember that you have the flexibility to revisit any of the course items. This might only be the start of your journey toward a career as a data analyst, but you can be very proud of yourself for how much you've already learned and accomplished. Now you're ready to tackle the course project and graded assessment quiz. Good luck, you've got this. Well done on completing this course. You should be proud of the progress you've made in your data analysis learning journey with Microsoft Power BI. Throughout the course, you explored how to extract, transform, and load data using Power BI in depth, gaining expertise in building ETL solutions using Power BI and Power Query. You explored collecting data from and configuring multiple data sources in Power BI, preparing and cleaning data using Microsoft Power Query, and inspecting and analyzing data to ensure data integrity. You learned about data sources and setting them up in Power BI, as well as some of Power BI's ETL capabilities, including connectors, storage modes, and setting up triggers. Plus, you discovered more about transforming data using Power Query. Whether you're cleaning and preparing data sets in Power Query to deal with errors and inconsistencies, or performing advanced transformations to combine data, you are now better equipped to transform data using Power BI. And don't forget that you now have more insight into loading and profiling data in Power BI, as well as performing advanced queries in Power Query. You even practice transforming multiple data sources, a key real-world skill for a data analyst. Congratulations on the expertise you've gained in extracting, transforming, and loading data in Power BI. This insight marks a valuable milestone in your journey to comprehensively using Power BI to unlock valuable insights from data. Completing this course contributes towards gaining the Power BI Analyst Professional Certificate from Coursera. These professional certificates are designed to equip you with the necessary skills to become job-ready for in-demand career fields. The Microsoft Power BI Analyst Professional Certificate, in particular, not only offers you the opportunity to enhance your data analysis skills, but also gain a qualification that can lay the groundwork for a career as a Power BI data analyst. Plus, the professional certificate will help you prepare for the exam PL300, Microsoft Power BI Data Analyst. By passing the PL300 exam, you'll earn the Microsoft Certified Power BI Data Analyst certification. This globally recognized certification is industry-endorsed evidence of your technical skills and knowledge. The exam measures your ability to prepare data, model data, visualize and analyze data, and deploy and maintain assets. To complete the exam, you should be familiar with Power Query and the process of writing expressions using data analysis expressions, or DAX. You can visit the Microsoft Certifications page at www.learn.microsoft.com/certifications to learn more about the Power BI Data Analyst certification and exam. This course enhanced your knowledge and skills in the ETL process in Power BI. But what comes next? Well, there's more to learn, so it's recommended you move on to the following course in the program. Whether you're new to the field of data analysis or already have some expertise and experience, completing the whole program demonstrates your knowledge of and proficiency in analyzing data using Power BI. You've done a great job so far and should be proud of your progress. The experience you've gained will showcase your willingness to learn, motivation, and capability to potential employers. It's been a joy to take part in your learning journey. Keep up the excellent efforts and best wishes for all your future endeavors.